maybe in 2 chapters. But when you get to CCNA 2, almost every chapter from chapter 3, there is configuration. So I enjoy doing the talk and then doing the configuration. Doing the talk, then show you how this thing works. That's why I prefer CCNA 2 and 3, especially CCNA 2 when I am teaching. So these are the objectives. So we're going to start with a switch. Configure a switch with initial settings. Of course, I believe we know what a switch is. A switch is a layer 2 device. You use it to aggregate connection on the network when you want to network systems together. And you need to know about how it functions or how it operates. And we're still going to talk about that in chapter 2. But then let's learn how to configure this as if we've never done this before. But this is going to be a revision. But before we go into the configuration, there are some stories we have to tell about the switch again in this particular chapter. I'm not sure they took care of this like this in CCNA 1. So we have to take care of some of these things here. Even though you were introduced to switch in CCNA 1, you did the configuration. At least this is going to be more or less like something to remind you. So the first thing we need to talk about switch is the boot sequence, switch boot sequence. After the Cisco switch is powered on, it goes through the following 5-step boot sequence. Number 1, that is step 1 now. The switch loads a power on self-test program stored in the ROM. When you talk about power on self-test, it's not only, let me say, anything that is computer, we have to go through this process. If you have done HIP loss or you know about hardware very well, when the computer and regular computer will do the same thing. They have to test for major components in the machine to be sure that these major components are working. So the power on self-test is the first thing that will be done. So after that, what happened? The power on self-test checks the CPU subsystem. It tests the CPU, it tests the RAM and the portion of the flash device that makes up of the flash system. When you talk about your flash device, that is where your IOS is resident. So the power on self-test will test major components before the operating system can load. It's the same thing that happens with a normal computer. It will test the CPU, it will test the RAM. That is for regular computer. But in this scenario, it will test the CPU, it will test the RAM, and also the portion of the flash. That is the container for the operating system. If all of these things are in place, that is when it can go to step 2. If they are not in place, the switch is not going to boot. Same thing with your computer. If there's a problem with your RAM, the computer cannot boot. If there's a problem with your hard drive, the computer cannot boot. These things have to be taken care of. We have to be sure they are intact. As a matter of fact, back in those days, even if your keyboard has issue, the computer is not going to boot. If you remove, especially when you're talking about desktop, if you remove the external keyboard, you unplug the keyboard and you try to power a system, the computer is not going to finish rebooting because it will discover that keyboard is missing here. Unlike nowadays, that post can continue and then the operating system will load. So let's assume everything is intact for our switch. The major components are intact. What happens next? Next, the switch loads the bootloader software. So what is bootloader software? The bootloader software is a small program stored in ROM that is run immediately after post successfully completes. When you talk about your bootloader, all of these things, they just have some set of instructions that this thing have to follow. It's like, I'm done with my part, I pass over to you. You have to run the set of instruction that is embedded in that firmware and before passing over to the next set of instruction. So now, when the post is successful, what happens? The bootloader, the instructions in that ROM, which we call bootloader, that one too has to run. So what happens in that place? That takes us to step 3. The bootloader performs a low-level CPU initializations. It initializes the CPU register, which controls where physical memory is mapped, the quantity of memory, and the speed. If you are familiar with 8 plus, you're talking about register. So many things to talk about register, but we're not going to go into that. This is still not far from post. The operating system cannot load right now. The iOS cannot load right now. So what happens again? Step 4. The bootloader initializes the flash file system on the system board. This flash here, that's where we have our iOS. So we want to kind of try to load the operating system. So once the file system has been initialized, that is when we can go to the last stage. And what happened at the last stage? The bootloader locates. How will it locate the OS? There is a set of instructions that will point to where the OS is resident, which is in the flash step, and load a default iOS operating system software image into the memory. And watch out, and give controls of the switch over to the iOS. And that is when you can access the command line interface of the switch. The moment you enter into the switch or even a router and you're able to access the command line, it's because control has been given over to the operating system. Now, in this scenario now, we don't just call the operating system of our switch or router OS. We call it iOS. That's the way Cisco refer to their own operating system, Internet Working Operating System. So you need to understand the boot sequence. And why is it very important for you to understand the boot sequence? If there is a problem on your switch or even a router, you need to have an idea and say something is wrong with this switch, or something is wrong with this router. And for some reason, you should be able to at least tell maybe it did not complete the post, or it passed post and could not go to step 3, which has to do with the bootloader. Or it has passed through all these step 2, it has passed through step 3, it has even passed through step 4, but the iOS is corrupted. Because sometimes the operating system can be corrupted, and that is the only way we can fix our switch or the router. If the OS is corrupted, we can fix it. But from our own experience, once anything that has to do with hardware on the switch, for some reason, that's the end here. I'm talking of when you drop it in the workshop, most of the time they cannot do anything about it. But if the problem has to do with the operating system, that's not a problem. We always try to have a backup of the operating system, just like you have Windows 10, Windows 11. You can just get the image, even though these are not easy to come by. That is why when you buy your router and you have your switches, you need to have a backup of the images. The images are the operating system that run on these devices. Have a backup of all of these images. And why do you need to back up all these images? In case you run into trouble in the future, you know you have a backup, you can bring the backup. Because the Cisco IOS is not something that you can just enter Computer Village in Lagos and say, I'm looking for Cisco IOS. I want to buy like a regular Windows 10 or Windows 11. It doesn't work that way. So you need to understand the boot sequence. That will give you an idea of where the switch is stuck, if you understand these things very well. And sometimes, even if you don't understand the details of this, as long as you have some information about where the switch is stuck, maybe the kind of link like is giving you, by the time you Google it, you'll be able to find out, oh, is the OS that's corrupted? Oh, is the flash that's corrupted? Because sometimes there's no problem with the operating system. The problem is with the flash. That is the container of the operating system. So it's like your regular hard drive. If the operating system, if the hard drive crashes, that's the end of the OS. So you can't put the blame on the OS. The blame is on the hardware. That is the drive that's kind of house the operating system. So both of them have to be in good shape. The hardware, that is the container for the operating system, has to be in good shape. It has to be okay, and the operating system also has to be okay. The same thing applies to your routers and your switches. As a matter of fact, I tell my students, I say, what do you think a router is? Even your switch, they are just special purpose computers. They run different operating systems. A regular computer has CPU, your router has CPU, your switch has CPU. A regular computer has RAM, your router has RAM, your switch has RAM. A regular computer has a hard drive, but in this scenario now, we don't call our NVRAM where you store the configuration file, we don't call it regular hard drive, but that is the same concept, non-volatile random access memory, where you store the configuration file and it's resident there. It can stay there even when there is no power, as long as it's stored there. That's just like the hard drive. So your switch, your router, they are just special purpose computers, majorly built to do networking stuff for us based on the instruction or the capability of the OS, the operating system. So these are just the switch boot sequence. So you power your switch and it's not booting, you need to know what's going on behind the scene. And the same thing applies to your computer. Now I need you to take note of something here. They said it will load the default operating system. So what does that mean? Sometimes I can have more than one operating system on my router. I can have more than one operating system on my switch. But I need to point my switch to the one it's going to load. It's like when you do the booting on your computer. You put Windows 10, you put Windows 11. By the time you power your computer, it's going to give you options. Which one do you want to load? You want to load Windows 10, you want to load Windows 11. You are the one to now select the ones you want to load. Similar concept. Just as in this scenario, we are not going to be telling the router or the switch every time. We'll just put a command in the router or on the switch. So whenever it wants to load, it will know that this particular it will know that this particular operating system is the one that it needs to load, because we have instructed our device to make that particular operating system, the iOS operating system, the default operating system. So anytime it wants to load, it loads that particular operating system. Most routers and switches come with just one OS. But sometimes you want to run another, maybe you want to upgrade the router and you don't want to get rid of the old operating system, or you want to upgrade the switch, you don't want to get rid of the old operating system. You can load another operating system as long as you have enough space in the flash. That is a container for the operating system. Once you have enough space there, you can add another operating system and inform the router or the switch, I want this one to be loaded anytime you are booting. That means you have designated that particular iOS to be the default operating system. Whenever it's loading, it loads that particular one. And that is what we achieve with this command, boot system command. You only need this command when you have more than one operating system on your router or your switch. If you don't have more than one, you don't need this command. So what is going to be the job of this command? It's going to point to where the operating system is resident and tell it, this is the one I want you to boot every time. So let's talk about boot system command. The switch attempts to automatically boot by using the information in the boot environment variable. If this variable is not set, the switch attempts to load and execute the first executable file it finds. So if I have just one operating system, I don't need this. I don't need to tell the switch to load anything different. Just go ahead and boot using the OS that you have. The iOS operating system then initializes the interfaces. That means my iOS is loaded now. Using the Cisco IOS commands found in the startup config file. I'm sure you must have talked about startup config file, running config file. When you configure your router or your switch and you save your configuration, it is saved in the NVRAM. The one running in the RAM is what we call running config file. The one running in the NVRAM, the one that is saved, is more or less like a backup. If NEPA should take lights or your switch should go off for whatever reason, or your router should go off, that one in the RAM, which is called the running configuration file, is gone. When else you power that device, where will the device get the configuration file? It goes to the NVRAM and loads the configuration file. But it cannot load the configuration file until the iOS operating system is done loading. When the operating system is done loading, that's when it will now load the configuration file, which we call startup configuration file, or sometimes we call it backup configuration file. And that is when the switch can now finish booting. But when it's done booting and it has affected your configuration file, That is when you see that the IP address you put on an interface is still there. The name you gave the switch is still there. Let me say, whatever, anything you have done in that configuration, everything is affected. Why? Because it loaded it somewhere. The startup config file is called config.txt and is located in Flash. What is the meaning of this? This guy just said the configuration file is located in NVRAM. Why is it now saying it's located in Flash? When we were students, we were taught that this thing is located in NVRAM. Down the road, they made us realize that you can store it in NVRAM, you can store it in the Flash. Flash originally was meant for the iOS. But down the road, maybe it was just an improvement or innovation, they now made us realize that even this startup configuration file, it can also be installed in the Flash. I can have it in my NVRAM, I can have it in the Flash. It makes no difference. So as sometimes some of these things we are discussing today depends on the model of the router or the model of the switch. It's like when you talk about computer now, you talk about Pentium 4, Pentium 3, dual core, core high 3, core high 5, core high 7. We're talking about different hardware capability. Because what a core i3 system will do, Pentium 4 cannot attempt it. And the kind of operating system or software that core i3 will support, Pentium 4 cannot attempt it. It's like now we have Windows 10. You carry Windows 10 right now and say you want to go and put it on Pentium 4 system. It's not going to work. So the more you have, the more hardware capability you have, the more of the software capability you have, or let me say the more software capability you also have, the more the demand for hardware capability. That's why when you go to buy a particular software, they will tell you the hardware requirements. So kind of CPU, so size of RAM, and the minimum space you need on your system. Even when it comes to graphics, they will tell you this is the kind of GPU you need before you run this kind of software. Same thing with operating system, same thing with regular software. So different capability is all about advancement, is all about innovation. So don't let this one confuse you that now the startup config is in the Flash. It can be in NVRAM, it can be in the Flash. In this example, the boot environment variable is set. So if I want to set my tell my switch where to load or the operating system to make the default, I need to use this command. And I'm going to show you, I believe it is in the slide there. If it's not in the slide there, probably in one of the labs, I need to show you how you can use the command. That is if you have more than one iOS on your system, on your router or your switch. But if you don't need anything. You don't need to do anything. So you use this command at global configuration mode. Notice that the iOS is located in a distinct folder. Of course, the iOS will be resident somewhere. And the folder part is specified. Look at the command here. I didn't even see it. Look at it here. This is my global configuration mode. Boot system flash. What am I saying? I'm telling the switch, listen to me. That I have more than one operating system in the Flash, but this is the one I want you to be loading. Anytime you want to load, go ahead and load this particular operating system for me. This is an operating system. That's the name of an operating system for you. Look at how long the thing is. Look at how long it is. This from here, C2960 Lambda K9 MZ.150. Why do I have it like 2 here? Is that a mistake? I think they drop it in another folder of another one. That's the way it is. If not, it's supposed to end here. So you can see now. So our pointing here is like this folder. This is a directory. This one was dropped inside this place. So we're pointing to the part where destin is. But originally, you can have them create a folder for them, have them in just one folder, and you just point to the folder in general and the OS in that folder that you want to boot. So this is telling us about, this is the command. Boot system is the main command. The flash is the storage where we have the, okay, I think I understand the way this one is. Okay, yes, I think I understand what they are trying to do here. So The boot system is the command. The flash is the storage device. And this is the path to the file system. So this is the file system here. And this is the real operating system itself. So this is our paths. That's the file system. And this is the real operating system. The one I've done in the time past, this is not the way it is designated. You just point to the image directly. You point to the flash and you specify the image. Anytime it's loading, it picks that one. And that's why I say sometimes it depends on the model of the router or the switch. If you take a look at this right now, the model of this switch is 2960 series. And guess what? If you have another switch now, and let's say it's 3550 series, this may not be the way, the command may be the same, but the way they put the part may be different. And that is why we always need documentation. Documentation is non-negotiable for us, for any hardware or any device you get. Because the way it is done on one may not be the exact way it will be done on another. The command can change, or the part can change, or the way you hand the command can change, so on and so forth. So this boot system command is basically needed when you have more than one operating system. If you don't have more than one, you don't need all of this. Sorry, I forgot to tell you, people, in case you have questions, you can just raise up your hand. You see a place to raise up your hand there. You can just signify. Anytime you can pause me by just raising up your hand, I'll give you the floor. Please. All right. Okay, so before I continue, let me find out, ask if there's any question. So we're still talking about switch. We're going to, when we're done with some of the story, we go to practicals and do revision with some configuration. We're going to build a basic local area network on our packet tracer, and then we're going to use that to do revision and then come back to the storage, the remaining storage that we have left. Any question? Prof, you are going to be the class rep. Hello, sir.
Though you have a very, very bad class rep who will not.
Okay, get us a class rep. Give us a class rep so that I can say.
Who will be a class rep between Ahmed and Mr. Taiwo?
Maybe I should nominate Ahmed. Ahmed will do a very good job for us.
Mr. Taiwo, please. Mr. Taiwo, please.
Mr. Ahmed has been too occupied class rep in the last time, so I think he can do it.
He has always been a good class. So,
Mr. Taiwo.
Class rep, I hope you are connected.
The reward for good work is more work.
It's more work.
You don't have any serious work here. It's just to probably remind me to start recording, because as we have right now, I'm recording. After the class, I send the recording in case you want to go over the class, or to say we need to take break, 10 minutes break, 15 minutes. Just to coordinate something.
No problem.
It's not as if you are not going to. I won't give you some chapters to teach for me. Don't worry.
So Ahmed, are you there? Is Ahmed there?
Yes, I can. I'm talking.
So who's our class
We
rep
can
now?
hear you now.
Can
You
you
are
hear me?
class.
Who's going to be our class rep?
I think Ahmed has been
Ahmed
unanimous.
has been the class rep, and let him continue.
Okay, to
Can you-
Mr. Ahmed. Yes, so confirmed.
Ahmed, we are not seeing our CEO.
Can you even hear me? I'm not sure you can hear me.
Are you sure
Yeah,
he's
we can hear you.
aware?
Ahmed, we can hear you. Show your face.
Nobody is answering that they can hear me. So I've been saying I'm okay with it.
Show your face now, because okay, you showed your face the other time. It's Mr. Taro that has not shown his face, but that's fine. So Ahmed is fine. Let's go
Okay,
ahead.
thank you. Thank you. Then another thing I need to talk about is if I'm too fast for you, just let me know. If I'm too slow, increase the speed, especially when I'm doing configuration. Sometimes I get that complaint that, students don't have the same capacity to receive some things. So some of them will complain, you are too fast. Some will say, you're okay, just go ahead. So I always try to find that balance in between the ones that are saying go ahead and the ones that are saying you're too. So please just feel free to express yourself, please. Feel free. We are all here to learn. Okay, thank you. Mr. Ahmed, you'll be the class rep. So you can help us coordinate when it's time for any class. Once we start the class, in case I forget to do recording. Anybody can remind me, I say, but we're going to be expecting you to help us coordinate that, to remind me if it's time for
All
a
right.
break. Yeah, to
All right,
remind
thank you,
me,
sir.
just anything like, yeah.
All right. Well, I don't know the time for break. Has that been established yet?
Prof, how many hours should we take before we go on break? 1.5 hours? And how many minutes for break? Or 2?
Ahmed, we said no break.
Yeah.
No, you have to take breaks, even if it is 15 minutes, 20 minutes break. It mustn't be long. We need to have,
We can take it around 11 for 15 minutes.
that would be 1.5 hours later, right? If we start by
Yeah.
8:30, 11
Yes.
o'clock, we take break. Yeah.
Okay,
Yeah,
so
we-
is it
Then,
15 or
then
10
tomorrow,
minutes?
yes, sir.
tomorrow we can finish. We can finish for 1:30 because it's Friday.
Well, what time do you want us to finish tomorrow?
Probably
I think we even
12:30
said
because
it's
prayer
12
is
o'clock,
1.
12:30.
No,
12:30.
No problem. No problem.
today it's not even going to be 1:30. We have
No, today is
discussed.
1:30. Yes, sir.
No, we will not stay up to 1:30. My
have discussed.
my target for today is chapter 1 and chapter 2. And
Okay.
they are not much. These are things that you guys have done in CCNA1. But tomorrow is a new topic entirely. I'm going to be teaching VLAN and inter-VLAN routing. And what I can do to help you people, I have a old recording of my VLAN and inter-VLAN routing. If I send you, I send it ahead of time, and you people listen to it, then tomorrow to be really make this work very easy once I start teaching that class. But today's class and chapter 1 and chapter 2, there are things that you people have done. You did them in CCNA1. But tomorrow we'll have a lot of work to do tomorrow, because I always like to teach VLAN and inter-VLAN routing together in one class if I am doing instructors training like this. So, but I will try to see how we can make that one happen tomorrow. Okay, so before we go to the practicals, let's finish some of the stories. Switch LED indicators. Indicators are very, very good. They are very important to us. Why are they important to us? From indicator alone, you can do troubleshooting if you are experienced in the field. From indicator alone, you can do troubleshooting. You can just look at a switch like this and say, something is wrong with this switch. Why did you say so? Based on this light. It's like when you plug computer to the switch, you expect there should be a link light on your network card. And there should be a link light on the port of the switch if you are in the server room or you are connected directly to the switch, not through faceplate. So link lights are very, they help a lot to do troubleshooting, but sometimes they can fool you. For instance, now the network card, the link light on your card, probably the bulb has gone bad, but the card is still working, but it's rare. So you need to be aware of things like this. And this one you are looking at here, it depends on the model of the switch. You don't see it like this in all the switches. That's why documentation is very important. So what is the meaning of this? If I look at this switch right now, and I see a light comes up here, what does that mean? On the sys. If I see a light comes up here on RPS, what does that mean? If I see a light comes up on start, what does that mean? If I see a light comes on duplex, what does that mean? Speed, what does that mean? POA, what does that mean? These are all the things to just give you an idea of what is happening to that particular device. It's like your car when you have a dashboard. I'm talking of the car that all the things are still intact, because most of the cars that people drive, except the Tokumbos, the good ones, they still have all the things intact. Those things on your dashboard will oh, you need to service this car, your fuel listening, the brake, all those sensors, if they are still working, those are indicators. You have them on the switch, you have them on the router. They can help you to do your troubleshooting, and people will think this is witchcraft. It's experience, and you know what you are doing. So these are just good stuff when you are doing troubleshooting. You can just look and be able to make some informed decisions straight away. So let's just go through. But take note, this is not like it's not like this on all the devices. There are some switches you see, you may not even see more than one or two of the link lights. I'm not talking of the ones on the port. I'm talking of the ones on this part of the body. Like this is another button here. They call it power mode button or so. Yeah, mode button. You see. So mode button, you always have it, but all of these start, especially duplex and speed, you don't get them on most of the switches. So it depends on the model. Because as a student, when I did my CCNA many years ago, I take everything out of the book and follow it straight. And then when I come across something and it's not like the way I was taught in the book, I begin to kind of get confused or contest it. So I try to differentiate that for my student. So let's go through this one after the other. System LED. What is the job of this light here? It shows whether the system is receiving power and functioning properly. If the bulb is still working, this is going to help you. If you plug the switch and this thing doesn't come up, you know that it's not receiving power. Take note of what I said again. If the bulb is still working, and most of the times the bulb always works, but sometimes they can go bad. What about the RPS, redundant power supply? Some of these devices have a place where you can plug them to two different power pack or power connector. The reason is if one of the power connector is gone bad or the plug, the other one can pick up automatically. And this is one of the best thing you can do whenever you are doing networking. Redundancy, layer 2 redundancy, layer 3 redundancy, layer 7 redundancy, even power redundancy. Anything you can do as far as redundancy is concerned, you do it. So when you buy some routers or some switches, they come with two connectors where you can plug them to power directly. But the two of the connector of the power connector will not be working simultaneously. One will be working, the other one is just going to be on standby. So if you see the light, if the light comes out, what does that mean? The backup has taken over. Because now, another thing I need to tell you about this, when the light is off, it means something. It doesn't mean something is bad. When the light comes up, it means something. For instance, when we come to, let's say, speed now, this switch can be a combination of 10 Mbps and 100 Mbps. So on some switches, they'll tell you when the light is off, it means it's running on 10 Mbps. When the light is on, it means it's running on 100 Mbps. So they combine two things together on that link line. That's why documentation is important. But if it is just one speed, if it is just 10 Mbps or if it's just 100 Mbps, I believe you people understand what I mean by 10 Mbps, 100 Mbps. Of course, you people must know that now. That's the speed. Megabit, 10 millions of bits per second. If it is just 10 megabit per second or 100 megabit per second, it's not a combination of the two. The link light must come up. So when it comes up, it must be green. What does that mean? It indicates the sport speed mode is selected. Port speed can be understood by the light associated with each port. Like this one right now. I think it has different, depending on the documentation, it has different link light it can show you to tell you whether it is 10 Mbps or 100 Mbps, if that is the way it is designed. If it doesn't show light at all, it probably may be running on 10 Mbps and not 100. So you need to have that understanding from the documentation. So it's the documentation that will show you. Or you can have in between. You can say green light means this, red means this, amber means this, not showing at all means this. That's why we need documentation. So I jump one. What about duplex? Back in those days, our switches can run half duplex or full duplex. What is half duplex? One way at a go, like one way, if you are driving on the road and you say this is just for people going. That's half duplex. Only for people to go or for people to come back. That's half duplex. You cannot have a combination of going and coming. So back in those days, the switches can operate in half duplex or they can operate in full duplex. So from this, you know whether the switch is operating half duplex or the switch is operating full duplex. But nowadays, we don't talk about half duplex again. Everything is full duplex. So that's why this is no longer relevant. Because this is to tell you whether the switch is running full duplex. This is to tell you whether the switch is running 10 Mbps or 100 Mbps. And the reason why they did that back in those days is if you plug a computer to the switch and that computer is running at 10 Mbps, that is the speed of the network card, the switch will come to the level of that computer so that they can talk at the same level. That's why you can have a combination of the two. But nowadays, most systems, minimum you have is 100 Mbps. So if you see a switch that's operating 1 gig, it can still talk to a card that is running at 100 Mbps without having to shift in between. It's part of the advancement in technology. The same thing with PoE. Does the switch support power over Ethernet? If it supports power over Ethernet, it will show you the status when it is in use. And any switch that supports power over Ethernet is the same cable, network cable that is carrying your data is also carrying power to help us power our device, most especially our access points. That is why you see, back in those days, when people put access point on the mast, they have to run power cable to the mast. But nowadays, they don't need to do that. The same network cable that carries data to that access point on the mast is the same network cable that will carry power to the access point on the mast, and that is because of this technology called power over Ethernet. And not all the switch support power over Ethernet. So if I know that I want to do a job, I need to power access point, I will not go for a regular switch that is not PoE. I will go for a switch that is PoE that can power all my access points, depending on the number of access points that you want to deploy. Like some people now in some environment, they don't even use wired stuff again, wired connection. You have wireless everywhere. That means most of their switches in that environment is going to be PoE switch. They're going to be PoE switches everywhere because they want to just have access point, power, wireless everywhere. So they connect to the access point connect to the switch, but the switch must be able to send power to power those access points. And it's not just about the switch supporting being able to send power. This switch, they come with different power rating. There are switches that will be able to probably power 10 access point, 5 access point, maybe 20 access point. If you carry a switch that can only power, or let me say the power is not enough to power 5 access point, if you plug power 5 access point to that switch, only 2 or 3 will work there. Let me take it further. Same thing with surveillance camera. Because it's part of our job as network engineers. Some people used to think surveillance camera installation has to do with some other engineer in the field. I can say yes if we are talking of analog. But when you talk about IP cameras, it's part of our job as network engineer. And those IP surveillance cameras also have to be powered. So how do we power them? We can use our PoE switch to power the surveillance camera, even though most of those cameras nowadays come with their own device that looks like a switch. They call it MVR. So you plug all the cameras to that device and they are all powered. And that device called MVR has a drive, an hard drive that can store all your videos and operating system that you can use to interact with that particular device. But we can still do that with our switch, but the switch must have the ability to be able to power all those cameras. So take a look at our mode button here. So what do we do with this mode button? The mode button is used to move between the different status, the different modes, start, duplex, speed, and like what? You can have some settings manually. Let's say now you want to change the settings, or you want to say, okay, if the light shows, if the red says, for instance, now if the red is saying 10 Mbps and green is saying 100 Mbps, from mode settings you can, this is old switch, don't forget that. From these settings you can decide to change how you want these things to be displayed, depending on what is in the documentation, if you are allowed to change those settings. If not, there's nothing you can do. The way it is, that's the way you are going to have it. So I cannot overemphasize on the importance of documentation on any of these devices that you buy. You may not come with it, but you can get it on the website to know, okay, this is the behavior of this particular device. But beyond that, we can do other things with our mode button. Okay, so these are another things you can get from indicator. You can have it off, you can have it green. When it's blinking green, majorly for our interfaces, our ports, it simply means that it's busy. You can have amber, you can have blinking amber. When it's alternating between green and amber, what is the meaning of that? So let's take a look at this one in particular. Let's take a look at duplex, for instance. Now, let's me take care of this. So when this link light is off, I didn't even know this one is here. What happens? It means there is no link or shutdown. When it is green, the link is up. When it is blinking green, there is activity. When it is amber, the port is blocked. Why is it blocked? To prevent loop. We're going to do STP in another class. You're going to see how the Spanish tree protocol blocks port. What about blinking amber? Port block, preventing loop. So what's the difference between the two? One is in the process of blocking, the other one has blocked completely. When it's alternating between green and amber, what does that mean? Link faults. There is a problem with that port, for instance. Okay, this is one of the things I was trying to explain earlier. For duplex, when the light is off, that means we are running on half duplex. When the light is green, that means we are running on full duplex. Same things applies to 10 Mbps. When the light is up, we are running on 10 Mbps. When the light is green, we are running on 100 Mbps. When it's blinking green, we are running on 1000 Mbps. That is 1 gig megabit per second. So documentation matters. You need to understand all of these things. From that documentation, you can interpret a lot of things as far as that device is concerned. So this is probably going to be the last slide I'll take before going to the practicals, and then we'll come back to the story. Any question? Okay, I presume there is no question. How do you recover from a system crash? The switch has crashed. Something has gone wrong with the switch. This one, it's easier for me to bring a router back than bringing a switch back. When I was a student, I would do something like that. But this is not difficult anyway. The bootloader provides access into the switch if the operating system cannot be used. Take care of that. Because of missing or damaged system file. Let me ask you a question. If your operating system crashes, now let's say your Windows 10 or Windows 11, the operating system has crashed. Can you still access an environment in that system that will enable you to do some things? Oh, of course. You can go to your BIOS environment. If you know the key combination to go into the BIOS, what will you want to go and do in the BIOS? Depends on what you are trying to achieve. For instance, now, if the system will not boot, one of the things you may want to go and find out from the BIOS, can this my system see my hard drive? Because sometimes the system not booting completely does not mean the operating system has crashed or the hard drive has crashed. Probably the things shifted. And if you can go to the BIOS, from the BIOS you can see the drive. If you can see the drive from BIOS, that means that drive is still on the system. That means the drive has not crashed. Similar concept. When the operating system on our switch has crashed completely or not fully crashed, some files are missing. It's like your Windows too. If some files are missing in your Windows, the Windows will try to finish the booting, it will not complete it. It can even give you an error message. Well, by the time you do your research, you discover that it has some missing files, and that is the reason for using a repair. You can run a repair. What is the essence of running a repair? You are trying to replace the missing files in the operating system, because this operating system that you see, there are millions of codes that put all these things together. One file gets missing like this, things will not go normal. Similar concept. So the fact that the operating system on the switch has crashed doesn't mean that we cannot access the switch. We can access the switch, which is more or less like the BIOS environment of the switch. And that is what the bootloader gives us access into. The bootloader has a command line that provides access to the file stored in the flash memory. And this bootloader can be accessed through a console connection following the first step. So how do we access the bootloader? We want to go into an environment that we are not familiar with. Why? Because the operating system has crashed for our switch. How do we access this? Step 1, connect a PC by console cable to the switch console ports. Configure terminal emulation software to connect to the switch. Sorry, Prof, have you people bought your lab bundles? Hello, sir.
Yeah, I didn't hear the question well.
Have you bought your lab bundles, the routers and the switches?
No, not yet.
Okay. That means there is no way for me to show you people this when I come. So we just have to
we
talk
have
about it.
routers and switches in our network.
Oh, no, I'm not talking of the one on the network. Oh, I'm talking of the one for the academy. You know, you need different set of equipment for the academy.
I know we haven't bought one of the things
Okay.
we think you guys will advise us on before we buy.
It's okay. It's okay. No problem. So this one we can only talk about it theoretically. We can't do this on packet tracer until you get the equipment. So we can try this when you eventually get the equipment. So step 2, they say you should first of all connect the switch to the console, because you see that's how we do configuration. I believe Mr. Wilson must have taught you need to have a console connection to your router or to your switch. Unlike the way some students do it, they will just bring a router out, double click it, and they're in. I'm going to show you that's not the right way. You can double click packet tracer router and packet tracer switches. You can't double click a live router and switch. You have to do console connection. So get used to doing this console connection, even though we know that you can double click. When you have mastered this, then you can now begin to double click and just go ahead. So now we connect our PC by console cable to the console port on the switch, or as for switch now, configure the terminal emulation software to connect to the switch. This software is a software that gives us a logical connection to our switch. There are different types. We have, what's that name? Oh God.
Putty.
You say?
I say putty, P-U-T-T.
I know we have Putin now, but there's one that used to come with Windows. Hyperterminal. I don't know if you've seen Hyperterminal, if you heard about Hyperterminal before. There's private edition. There's one that used to come with Windows. Back in those days, Windows XP. There are other ones. There is TerraTime also. These are all terminal emulation software that you can use. So that will give you a logical connection to your device. Step 2, unplug the switch power cord, because we're going to plug it back. Step 3, reconnect the power cord to the switch, and within 15 seconds, press and hold down the mode button. That button I showed you earlier, you press it down. While the system LED is still flashing green, that system LED we saw, what do we do? Step 4, continue pressing the mode button until the system LED turn briefly amber, because what you are simply trying to do, you are trying to disrupt the boot sequence. We can do the same thing to Windows. For instance, if I'm on your system right now and you power the system, I can disrupt that boot sequence by making your system to boot into, let's say, safe mode, or even to the BIOS. I can disrupt it. So what we're trying to do is we want to disrupt the boot sequence. Why? Because we want to access an environment that will enable us to restore this switch back, because the switch has crashed or the operating system has crashed. So in order for us to disrupt the boot sequence, we need to use the boot mode button and watch out for some things. And what we watch out for is this system light, this system LED. When it turns, look at it, briefly amber and then solid green, then you release the mode button. Guess what? When you release the mode button, what happens? Step 5, the bootloader switch column prompts appear. You guys have never seen this when you are configuring. When you are configuring your switch, by the time we enter switch now, we're going to enter into switch greater than sign. That's all you see. Then from there, you move to privilege mode. That's all you see. But by the time you enter into your switch and you are seeing switch colon, you are in a different environment. You are in the spirit realm. The language you speak in this place is different. And why are we here? We're trying to restore the operating system of the switch. It's more or less like going to the BIOS, trying to say, okay, load from my flash drive, because you want to now install the operating system. You change the boots, what do you call it? The boots, I forgot what they call it. That's where you should load from, and stuff like that. So when you get to an environment where you see switch colon, you intentionally decided to go to that environment because you want to reinstall the operating system. And sometimes it's not just the operating system. Even when the password on the switch is forgotten, you can also use this environment to restore the password. Like we do have problem with our, this is not the only way to restore password. Students, We tell them when you are configuring your Cisco, our Cisco routers and switches, your username password should be Cisco and your privilege mode should be class. But you trust students. Some of them will not use any of this. So if another student wants to use the device, somebody has passworded the device with a different password that we're not aware of. So what do? We have to do password recovery. There is a better way to do password recovery than this one. But when it comes to reinstalling the operating system, there's no shortcut. You got to go through this environment. So now I am going to go into the packet tracer to begin to do some labs. Then I will come back to the stories here. Are we good?
Yes, we are.
Okay, thank you. So I want to work on, let me just design a topology. Let me say, oh, it's not this. So let's build a basic local area network. Let's have a LAN here. This is our switch. And in this LAN, I have decided to use 192.168.100.0/24. Then two computers will be here or more. We have another local area network. This is our switch. And we'll have two systems here. And we want to link these two local area network together because we've decided to do segmentation. This is my router. I'll link the switch to the router. Link the switch to the router. From this network now, I want to give this interface on my router an IP address. From this network now, I want to give this interface of my router an IP address. And on computer A, I want to give an IP address. Computer B, an IP address. Computer C, an IP address. Computer B. Also, my switch as a whole needs an IP address. The switch as a whole. So what do? I can decide ahead of time. My router, the interface on this side, let's call this one LAN A and call this one LAN B. The interface on this side, I want to give my router 192.168.100.1. My switch as a whole, I want to give my switch 192.168.100.2. Of course, going to be /24. Then my computers here. This one I can give this one 192.168.100.3/24. Then 192.168.100.4/24. Then on the other side of my router here too, similar stuff. Don't forget this leg of my router is on this LAN B. This other leg is on LAN A. So I want to give this one 192.168.101.1/24. This switch here as a whole, I want to give the switch 192.168.101.2/24. And the computers here 192.168.101.3/24. Then the second computer 192.168.101.4/24. Please let me be sure that we're on the same page. This IP addressing that I wrote, we are okay. We know, I believe you guys have done IP addressing. You know the classes, you know the meaning of /24. You know when I say these are on different networks. Let me be sure that we can still remember all of this. Prof.
Yes, we do, sir.
Get on. Okay, thank you.
Yes, we did. And
You said you're saying something, sir.
we are familiar, we were taught, and we
Okay,
know.
good.
Thank you.
So this is what we want to build in order to drive a point home on this particular chapter. We're going to build local area network, just small one, 2 LANs, a router to do segmentation. So let's move to packet tracer. So This is my packet tracer. I'm going to bring out all the things needed. It's like when you get a contract, you need to buy all the things. I need a router. Any of the routers will do. I'm a fan of 2911 series. Then I need switch also. I like 2960. So I bring 2 out. And then I need 4 computers. It can be desktop, it can be laptop, it makes no difference. 1 computer will do us, but they just add 2. So I got all my devices. I need to link them up. I can use the automatic cables. Look at automatic cable here. So what is automatic cable going to do for me in this packet tracer? It's just going to put the right cable for me. But in the real world, or let me say when we're teaching, we tell our students, when you are using like devices, crossover. Unlike devices, straight through. So ideally, if I want to connect my computer to the switch, I should use straight through. I want to connect the switch to the router, I should use straight through. But what about switch to switch? Crossover. Router to router, crossover. Computer to computer, crossover. Because these are like devices. That is the ideal thing. But what if I use the wrong cable? I carry, let's say, crossover cable to connect my computer to the switch. Will it still work? Or I carry crossover cable, straight through cable rather, to connect switch to switch. Will it still work? Nowadays, yes. And I'm going to tell you why. Because I argued this with somebody many years ago. He's been a feed guy. He was going to link 2 switches together. When I followed him to learn in the feed, I said, no, this thing no work. Why will you use straight through cable to link 2 switches together just to extend the network to another building? He said, don't worry, we've been doing this thing. You are a book guy. You're just finishing Cisco. He himself couldn't explain to me why the thing works. He does know that it works. It was many, many years down the road when I was preparing for my CCIE in 2012 that I got to know why this thing works. And now they put it in the curriculum to let you know that this thing can now work. So you don't really need to be crazy about straight through cable or crossover cable. But in the exam, when you're writing, let's say your exam or certification, if you do see any question like that, you still have to stand by like devices, crossover, unlike devices, straight through. But in the real world, anything goes. So let's just follow the rule here. My computer to the switch, I need a straight through cable. Look at my cables down here. I believe you people can see the cables here. Look at them here. These are all cables here. Look at cables here. So this is my crossover. This is my straight through. So I will carry my straight through cable. I can press down control because I have multiple connections to do. It will just keep the cable for me before clicking it. So I come down here. Look, I have multiple ports here on this my computer. I want to use fast Ethernet because that is the LAN connection. Go to my switch, multiple ports on the switch. I connect to any of the ports. Switch to router. It's also straight through. I have multiple ports. This is the console port I will use for configuration. I am not about to configure the router now. I just want to set up for network connection, for data to flow, not for my administrative purpose or management purpose. When I want to connect to configure my router, we're going to use the console port. So I use any of the ports here. So let me use 00. Carry another port, connect on the other side. So I don't have to be picking the cable again and again and again and again. Once you press that control button, the cables just keep on following you. So I can return the cable by pressing this even when I'm done. So yes, Mr. Omotayo, please go ahead with your question.
Yeah, I'm practicing as you're going in, but I wanted to ask: is there any way my packet tracer could usually show the interface that I'm connecting with?
Of course, now. Oh, mine is showing. Is not showing.
Yeah, as you're seeing, for example, in your
Okay.
computer laptop one, you're seeing fast.
Let me show you. Let me show you. You go to, I think, option and then preference. Can you see this option?
Yeah, option, yes.
Then go
Preference,
to
yes.
preference. Then look for show device model. Oh, no, that should be interface now. Always show port label. I think it's this one
Okay,
here. Show
yes, I've
port
seen
label.
that.
Select it.
Okay, it's working now. Thank you so much.
You're welcome, sir. So now I have done physical. I mean, I have created this my topology for network connection. This is not for configuration. So if I want to configure this switch, or I want to configure this router, any of the switches or the router, what do I do? In packet tracer, what people will do, they will just double click the packet tracer and they will go to CLI and they are there. No. In the real world, you can't double click a live router. You have to do console connection. So that is why, because you need to go with a laptop, a separate computer to configure that device. So we want to start this configuration with our router. What do we need? We carry a different computer. I go to my computer. Excuse me. Carry a different computer. It can be laptop, it can be desktop, it makes no difference. I bring out here. Then go to cable and then select console cable. In the real world, you use console cable to connect to the router or to the switch. Select my console cable. Click the computer. Select RS232. That is our COM port. We call it communication ports. Now, back in those days, you see it's like your serial port where you connect the VGA, something like that. That's the male version. But nowadays, we use USB. There are console port that comes with USB and it's software. So we don't really use the regular old school console port. But in packet tracer, we still use COM port. So, and the COM port in this scenario is RS232. So I'll select this COM port. What do I want to configure? My router. I'll take that cable to my router, click my router. Where do I plug this into? Which of my ports is a management port? Console port. I will select console and I'm done with physical connection. For you to configure your router or you to configure your switch, you need two types of connection. There must be physical connection and there must be logical connection. The physical connection is the one that you use the console cable to do, but the logical connection is the one that you use your software in the operating system to connect to the router, because you are going to put in some settings like the hyper terminal. I don't know if I still have it. I installed one private edition for my student. Good. Look at it here. Hyper terminal private edition. So let's assume this my router, my laptop is connected to a live router now, physically through using a console cable. And I have this on my system. So what will I do? To set up a logical connection, I'll click this hyper terminal. It will ask me for some settings because, this one has expired. It won't launch completely. It will tell me to put a serial, this thing, and all of that. It won't show you what I would like to show you. But when I first installed it, it was a trial version. It was showing me. Back in those days, Windows gives you this free. It doesn't belong to Microsoft, but I think they bought it also. They not bought it. They kind of collaborate together to have it on XP. But since Windows 10 came in, it was 7 rather, it was absent on 7 upward. So you can use the upper terminal, but then since we don't have upper terminal to use, I can also use TerraTerm. I think I have TerraTerm. Look at TerraTerm here. I can use TerraTerm. I clicked the TerraTerm. I put in some of the settings here. So what am I trying to do? I'm not trying to telnet. I'm going to talk about telnet later. I'm not trying to SSH. What do you want to do? I want to have a serial connection. This is TCP, meaning as an IP address. I want to have a serial connection. I will select serial. I will now select the communication port because sometimes you have more than one communication port on the device. And then click OK. And you are going to be in, all things being equal. But for TerraTerm, you have to set some parameters, which we are going to also see in packet tracer. So let's check them out. Don't forget, you first of all establish a physical connection. Then you establish a logical connection. The logical connection is using your upper terminal, TerraTerm, or even Putin. You can use Putin too to also do that. You can use Putin to also do that. Okay, this is putting. If I want to use serial connection, I select serial and select my communication port. So any of these software can be used to connect to your devices. But let's see what we got in Packet Tracer. I'll click this computer. I'll go to desktop and then come to terminal. See terminal here. Come to terminal. In hyperterminal software, the old one, this is the way it is. You're going to see all of these settings. They tell you port configuration. Set the bit per seconds. That's the speed at which you want to talk to your router as far as this configuration is concerned. Data bit, it tells you to put it on 8. Parity, it tells you to put it on none. Stop bit on 1. When you get to flow control, if you are configuring a router, back then, they tell you to put it on none. But if you are configuring a switch, they tell you to select hardware. We don't follow all these things again, and things we are able to access our devices and do configuration. So this is more or less like an imitation of that hyperterminal software, but it still will not do justice because here you cannot select the communication port. But in real life, with hyperterminal software, you can select the communication port. So if I click OK here right now, bam, what happened? I'm in the router. So anytime you want to configure these devices for the starts until you get used to these things, set up console connection. When you are teaching your student, make it compulsory. They must set up console connection so they get used to it before they start double clicking the router or the switches. Because in the real world, you are not going to double click these devices. So when I enter my router for the first time, what will I see? Would you like to enter the initial configuration dialog? What is that dialog all about? That is for babies in networking. That is for people that don't really know much about this. They just have some knowledge. So the router want to give them opportunity to just be putting some details like which name do you want to give this router? Which IP address you want to put on this interface? You just it will be asking you a question and you'll be answering it. That's not what we want. We are gurus. We know what we are doing. We don't want that initial configuration dialog. So I'll say no. I don't want that. The moment you hit enter, it will tell you press return to get started. Return in this context is our enter key again. I will press return key. And guess what? I'm in my router. I'm sure you people have done the basic configuration of router and switches. So I'm just going to start. Probably I may omit 1 or 2 commands, but I will just do it based on what I used to teach my students. I tell them, once you have phase 1 of your router configuration, even the same thing with the switch, and you have phase 2. What is in phase 1? All the basics, like giving the router name, putting binary MOTD, like passwording the user's interface, passwording the privilege mode. That's the basic. What about the second phase? Assigning IP addresses to the interfaces of the router. That's what I call second phase. What about the third phase? When you want to do routing, you can begin to do routing and configure routing protocol. Every other thing, they are in between. They are not compulsory for you to make your router work. But this phase 1, phase 2, phase 3, we are good to go. Things will work. Other configurations are in between. So what do we do now? This environment you see now is what we call users mode. I can't really do much in this environment. So let's assume I want to find out what are the commands that I can use in this environment. I press question mark. Question mark will show me all the commands available as this users mode. I can use session. You can't know all of this command. I'm just trying to show you. Connect command, disable command, disconnect, enable, exit, log out. I can ping here. I can resume. I can do show. I can SSH. I can telnet. Okay. Okay, that means your privilege is very low here as an administrator, as a network engineer. And that is why in an environment where you have a big network, you have the senior engineer, you have the junior engineer. So what the senior engineer will do is we give the junior engineer access to the user's mode. Why? To be able to do some tests, maybe ping to find out to test if there's connectivity, or use some show command, check this for me or check that for me. but it's not going to give you the keys to the kingdom where you bring down the whole network. So where do you get the keys to the kingdom? We have to go to the next level. How do we access the next level? The next level is called privilege mode. We type this command, enable. Guess what? When we enter this router now, this router didn't ask us for any password. Because it's a new router. No password asked. And we cannot afford to leave our device like that. So we need to be able to put password. Before we can access the privilege mode next, we have to put password. So where do we get to that environment? We need to improve or get another privilege. So before we can do anything like that, we've got to go to another level. So the first level we can access, or the next level we can access from this environment, is to go to privilege mode. How do you get to privilege mode? You type enable. Enable is a command. What does it do? Look at it here. Look at it here. It turned on privilege commands. So if I hit enter right now, my prompt has changed. It changed from greater than sign to hash. And the greater than sign is called user executive mode. The hash sign is called privilege mode. So I am at the privilege environment right now. Let's check out the things I can do in this environment. Same question mark. Oh my
Hello?
goodness. Are you asking me a question?
Okay.
Hello, are we together?
Yes, sir.
Please, you need to raise up your hand before you talk. But you can go ahead now. What's the question?
No, I wasn't asking a question. I couldn't hear you anymore. So that's what I was.
Okay. Prof, can you hear me?
Yes, we can hear you from this side.
Yes, yes, I can.
Okay. Then probably it's your own network.
Most likely.
But you can hear me now.
Yes, I can. I can.
All right. Thank you. So look at the commands that I can issue from this environment. Now, you can see I can scroll down. Anytime you see more here, you press your space bar. That means you have more commands done. If I press more my space bar, I have more commands down. Now, all these commands you are seeing in this environment, it's not as if you just issue the command and that's all. Some of them have other commands inside. For instance, now, we are in privilege mode now, and I'm still not satisfied with where I am. There are some things I cannot do in this environment. For instance, I can't give the router name in this environment. So where do I go to? I have to go to global configuration mode. How do I access global configuration mode? Look at the command here. I enter global configuration mode. My goodness, I have gotten the key to the kingdom. I can continue from there and do and undo and do and undo and do and undo and do so many things. So the fact that you see all these commands like this, there are other commands that you can issue within those commands. So now that I want to go to global configuration mode, that is where I can start doing make some changes to my router. That is where I can assign IP address to my router and do so many things. So what do? I type configure. You can type tab key to complete it. If I just type configure and hit enter, what is going to happen? It's going to tell me you are trying to go to what do you call it? Configure from terminal or memory or network. You can answer this question, but this is not what I want. I want to go to terminal directly. So instead of that, I will say, let me quit this. I will say, oh, it still took me to terminal. This is not what I'm trying to show you. I will say configure terminal. I want to configure from terminal. I have other options, but that's not where I want to go to. Configure terminal. What am I trying to do? I want to go to an environment where I can begin to change some things on my router. Same thing applies to the switch. If I hit enter right now, look at my prompt. My prompt has changed to config in bracket, then hash. This is what we call global configuration mode. This is when you get the keys to the kingdom. But even at that, a senior engineer can decide to give you access to some command at this environment that you can run. and not be able to run some other commands. But that's beyond CCNA. So what are the things we can do in this environment? If I put the same question mark, you see that there are lots that can do. More things can be done in this environment. And some of these commands you are saying here, they also have other commands that you can run within them. So right now, I'm at global configuration mode. And I can begin to do wonders from here. So the first thing I want to do is I want to give this router a name. And why would you want to give the router a name? It is very important to give your router a name, especially when you want to come to troubleshooting. Like in your environment, maybe you have more than one router. If you are the engineer, you are trying to resolve some problem remotely. How do you know the router you have entered into or the switch if they all have the name as router? So you probably will put, okay, let me use for example, because most of the time people have only one router on site. Let me use for instance a switch. There are, let's say like you have 10 switches. You need to be able to differentiate between the switches. Maybe switch A, admin block, switch B, accounting, switch D, this department, and so on and so on. You need to find a way to differentiate between them. So naming is very important. The naming and the naming convention, depending on the organization. So right now, I'll just give this switch, this router a name, and the command to give the router name is host name. Host name. I want to give this router name, so let's say Nile _ uni. I hit enter. You can see that the name of my router has changed to Nile uni. You can give any name you want. That is the first thing we always do when we access our device. You give the device a name. What is the next thing you do? Password your users mode and privilege mode. You realize when we came in, nothing was asked from us. No password was asked. We just entered. So we want to password the privilege and the users mode. How do we password the users mode? From this same environment, global configuration mode, you say line console 0 because you are coming in through the console port. Don't forget that. You are coming in through the console port. Line console 0, that is the first line there. The 0 there is the first line. I hit enter. Guess what I got here? Config line. This is called line configuration mode. So right now, I want to password this console port so that when somebody tries to console into my router or to my switch, the router will ask for the password before it gives access to the user's mode. So the command to give password is password, let's say Cisco. The command is password. The password is said is Cisco. So if I hit enter right now, I have put a password on my console port for user's mode. But guess what? If you stop here, it's not going to work. You have to log in the command, meaning telling the device as effect this on that interface by putting login command. If you put login command, you hit enter, guess what? This device has taken Cisco as its password. Let's test run this and see if it's going to work. But before then, let's save our job, because if we don't save this, when next we come, all these configurations are gone. So I go to privilege mode. You can press Ctrl Z on your laptop to take you to privilege mode. What do I want to do at this privilege mode? I want to save my configuration. How do you save the configuration? Copy is a command. That's why we call this what we're doing right now. We say we're at command line. This is not GUI. Running config. What is my running config? Remember I spoke about this thing earlier. That is the configuration file running in the RAM. All these things we have configured right now, they are still in the RAM. They are not yet saved. If you off this router now, that's the hint. Copy running config, startup config. What is startup config? That is my backup configuration file in my NVRAM. But guess what? I can also save that into the flash. But that is not where the router loads from automatically. If I go down and put question mark right now, you see that I can copy and save in my flash. I can save in an FTP server. I can save in another secure FTP server. I can save in my NVRAM, and I can save in my TFTP server. But this is the one I want. So I'm going to tell my router, copy running config, spacebar, startup config. I am simply saying, copy what you have in the RAM. All this configuration that we have done right now, put it in NVRAM. The one in the RAM will still be running, but we need a backup in the NVRAM. Why? If we power off this router right now, or we reload this router, it is going to load that configuration file, the startup now, which is the backup, effect it. Whatever we have put there, it's like writing a program before we can go ahead. So what do? We hit enter. It will not tell you this file you are trying to save. I am going to call it startup config. Are you okay with that? If you're okay, you hit enter and it's saved. But if you don't want to issue this long command like this, there is this old command and it still works. It works. It is called write. Write is an old command on our devices. It still works. It says from RAM into NVRAM. If I hit enter, it will do the same thing for us. Now that we are done with this, let's get out of this router and come back. We can do it in two ways. We can exit from the privilege mode, exit from user mode, or reload our router. So let me just exit. Now that I'm out, I want to go back in. I'll press enter. Why is he asking us for password? Because we told this to ask us for password. So this is your first line of defense into your router. We have passworded this mode, and we gave the password as Cisco. So now let me give the password Cisco. You are not going to see when you are writing it. I'll hit enter. Now I'm at users mode. But guess what? We want to go to privilege mode. We type enable. We have not passworded the privilege mode, so it's not going to ask us for password, and that is not good for us. So we have to password that privilege mode also. So it's like you have first line of defense, second line of defense. If it's possible to have the third one, you are going to have it. So now, how do we password the privilege mode? We've passworded the users mode. We want to learn to password the privilege mode. That one is very simple and straightforward. Just one line of command. We're going to get that one done. So I'll go back to my global configuration mode, config terminal. And for me to password my privilege mode, I will say enable password. There are two ways. Let's start with the first one. Enable password. I'm simply saying the password for privilege mode, because we have to type enable command before we can get to that privilege mode. Let's call it class. Enable password. That means the password for privilege mode. Anytime I type enable, I want to go to privilege mode. This is the password for it. I will hit enter. Let's save our job again and then exit and come back. Now this time around, I don't want to go to privilege mode to go and save. I can save from any environment, but I need to add do. So I'll say do writes or do copy running config, startup config. If I hit enter, it saved my job. So let me go get out of this environment and then exit. We're back. We're out again. It's asking us for password. So which password are we going to give now? I need answer. You can type. We have two passwords here. One is Cisco. The other one is class. Which one am I supposed to give? You can type the answer. You see a place to type, to chat. Okoyemi said class. Any other answer?
I think it's Cisco, but my system is acting up. You're not hearing me.
I can hear you.
Okay. I think it's Cisco. I guess we're entering into the router for the first time.
Thank you. We put Cisco for users mode. Mr. Koyemi, class is for privilege mode. Cisco for users mode. Class is for privilege mode. You need to be able to differentiate between the two. So let's check it out. I am in users mode right now. I put Cisco. I want to go to privilege mode. I hit enter. It's asking me for password again. Why is he asking me for password again? Because we put password. And the password is class. And here I am at privilege mode. So we have secured our users mode. Mr. Koyemi, I hope this is clear to you. Mr. Koyemi, can you respond? Okay, good. Thank you. So we have put two different passwords right now. One is Cisco, the other one is class. We have passworded, or we have secured our users mode, and we have secured our privilege mode. Is there another thing we can do? Can we do better than this? Let's find out. The password we put. Do I take care of that one first? Let me take care of it. There is one more thing that we have not secured. When I am coming in remotely to access my router, that is called remote access, and that can be done with Telnet or SSH. When I am coming in remotely to access the user's mode, the password is going to be different. Let me say the line I am passing through is different. When I console into my router, I am passing through the console port. But when I'm coming in through Telnet or through SSH, it's like I'm coming in from a different line completely. So we need to also secure that particular Telnet access or remote access. We need to secure the remote access. But I would like to demonstrate that, so I won't want to configure it now. Let's finish our configuration, then I will come back there. I will come back there because I want to show you that if I don't configure it, can I telnet? We are going to telnet and try to enter other devices. Then I will now show you how to password it. So we're supposed to configure our line console 0, our line VTY, and our enable password. But I'm going somewhere right now. Let me show you. For this privilege mode, we can do something. We can do better. For users mode, we can do better. What can we do? Let's check how the configuration file that's on our router right now, that is running on our router. Command time. Command is show running config. You are going to learn so many commands as we proceed. Show running config. Router, show me what is in your RAM. I will hit enter. So you can see, I can see the version of the operating system running. This is my configuration file. This is the host name we put. Can you see something here? Our enable password, the password is class. So if somebody is watching behind me right now, the person can say that, okay, this guy's password is class for privilege mode. What about the line console? If I go down with spacebar, you can see line console 0. Oh, the password is Cisco. Okay, so the person has grabbed my login password for users mode and privilege mode. So they felt this is not good enough. Can't we encrypt this password in case somebody is watching behind? The person cannot see. Oh yeah, we can encrypt this. So how do we encrypt? Very simple. We go to global configuration mode and we say service password encryption. Service password encryption. If I hit enter, get out of that environment, issue that command again, see what is going to happen. My enable password. This is it here. It's difficult to read this if you are watching from behind me. And they wrote 7 here. What is this 7? I'm coming to talk about that. Let's go down and check our line console. Our line console password. Look at it here. It's difficult for somebody to make sense of this. So it therefore means our user's name password and privilege mode password have all been encrypted. But this kind of encryption, level 7 encryption, is weak. Can we still do better? For privilege mode, we can do better. But for line console 0, for now, there's nothing we can do about it. Level 7 encryption is weak. There is a software called Cain and Abel. If you copy this in right now, put it on Notepad and launch Cain and Abel and put it there and generate it to show you the password. So this is weak. Level 7 encryption, we can't go with this. So what can we do? We can further protect our privilege mode password. And that is why when you are giving your enable secrets, enable password command, instead of saying enable password, we will not say enable password, we will say enable secrets. Why do I want to say enable secret? Because I want a stronger encryption for my privilege mode. Enable secrets. So whenever when you get to privilege mode, don't just say enable password straight. Go straight to enable secrets. So I can now say class. It will tell me that I already have one. It will override. But let me just say to change it to class 1. It will override the other one. By the time I hit this enter, go back to that environment, do show run, you can see the old enable password. This one is level 7, it's still there. Look at the new one now. This is our MD5 encryption. The other one is MD7. This is more secure. It's difficult to crack or break than the level 7 encryption. So for line console 0, we are stuck with MD7. For privilege mode, we have improved on the encryption algorithm. So if you are looking behind me, you can't make sense of my passwords. And if you should copy, it's a little bit difficult for you to crack my password because I have put a stronger encryption algorithm. These are the things that are recommended for this level. We are also going to do similar stuff, even though our line V2Y, which is for telnet, is also going to be using level 7 encryption. But at least we've been able to secure the user's mode. And I need to tell you something. It doesn't matter how you are coming in. All of you must come to the user's mode first. It now depends on how. If you are coming in through the console, you give me the console password. If you are coming in through line V2Y, you give me line V2Y password. But I don't want to configure line V2Y right now. I want to show you that you can telnet into devices because there are no password there. So we will now put password and see that this thing has you for password before you access the user's mode. Is that clear? Are we good?
Yes, sir.
Okay. So let me write the addresses we have decided to use on the topology. Okay, so now let's go and configure the router on the IP address for the router for LAN A. Don't forget, this is our LAN A. And this is our LAN B. So I want to configure my router for LAN A, meaning I want to configure this interface here, gigabase 0/0. Now there's another, we're still going to come to line V2Y later, but I want to telnet first before I come back to that one. And you can also put banner MOTD. Those are also optional stuff, so that whenever somebody enters your router, it will display something like, don't even think about it, or get out of my network, something like that. So how do we configure IP address on this router? Go back to our router. The interface that is connected to my LAN A is gigabase 0/0. I want to enter that interface right now. Don't forget the show command, show running configuration, shows you what is in the RAM. So now I want to enter into the interface right now. I go to my global configuration mode. You can shorten it, conf-T. How do I access the interface on my router? Interface gigabit 0/0. I want to enter that interface. I'll hit enter. Note, my prompt has changed to config if. This is what we call interface configuration mode. If I issue question mark right now, you see all the commands that I can issue on this interface. Plenty. But we don't need all of this. So what do we really want to do? Probably 2 commands. I can put description, which is good for you. Description is like, okay, interface that connects to my LAN A. It's for your own good when you are doing troubleshooting. And I also need to put an IP address. So 2 commands for now. So I'm going to say first, description is optional, it's not compulsory. Connection, or let's say connection to LAN A. Can put IP address first before the connection, it makes no difference. Before the description rather. So I'll say IP address 192.168.100.1. That's what we decided to give based on my topology. The subnet mask 255.255.255.0 because we are dealing with class C. Default class C is not been subnetted. What's the next thing? Okay, I said 2 commands, actually 3. This interface is shut down by default. Unlike your switch, the interfaces on the switch are on by default. So I'll say no shutdown. No shutdown is activating the interface. I will hit enter. I am done with that interface that connects to LAN A. What about the interface that connects to LAN B? Is gigabit 0/1. We can see it here. I'll go into that interface. You can get out from here first. You can exit. And also interface gigabit 0/1. IP address 192.168.101.1. Subnet mask 255.255.255.0. I hit enter and put my description, maybe connection to LAN B. And then the last thing is to say no shutdown. And guess what? I'm done with this router. For now, I can hit save my job. I'm done with phase 1. I'm done with phase 2. Now, even though we have not done any configuration on our switch, your switch can work as plug and play. We can go to the computers on our switches right now, give them IP addresses based on the network they belong to, and they will be able to talk to our router. They can ping themselves. Let's check it out. Let's check this out. One of my computers, I decided to give .3 because I want to give the switch .2. So I'll click this, go to desktop, go to IP configuration. We're giving static IP address, not DHCP. So I'll say, okay, you are 192.168.100.3. What is your subnet mask? The moment I click this place, it puts default subnet mask for me. Mind you, if you have done subnetting, you have to edit this. What about default gateway? What is a default gateway? If I need to go out of my local area network to talk to somebody somewhere, I need a gateway to go out. And the default gateway is that IP address that we put on the leg of on the interface of the router that connects to that LAN. And that is 192.168.100.1. DNS server. We're not going to the internet right now. We don't need this. I'm good to go. I'll close this. I'll go to the second computer. Give the same thing. 192.168.100.1. .4. Subnet mask. What about gateway? They share the same gateway because they belong to the same network. We are done with that. So let's go to the other side and also give them their own IP addresses also, those computers there. Don't forget, we've not touched the switch at all. Desktop, IP configuration. No, .3. The gateway is 192.168.101.1 for the people in LAN B. Same thing to the computer. .3. No, that should be .4. Subnet mask. Yeah. Now I am done giving all these computers IP addresses. We have given our router its own IP address or the IP addresses. Let's test for connectivity. So first of all, test for connectivity between the network, between local area network. Then we'll see if they can ping their gateway and they will try to go to the remote network, or let me say the other segment of the network. So I go to my switch, then my computer, the first computer here, go to command prompt, verify the IP address this guy has. Be sure it's correct. IP config. Okay, I gave this guy .3. This is subnet mask. This is default gateway. It's all right. So you are .3. Let's see if you can ping your colleague in your network. That's .4. So I'll say ping 192.168.100.4. Bam. This guy can ping person within his own network. Can you ping your gateway? Because if you cannot ping your gateway, then you can't get out of this network. Okay, ping 192.168.100.1. Bam. This guy can ping his gateway. So meaning there is possibility, there is hope of going out. So let's travel and go to the other side. Ping 192.168.101. We have somebody on .3. Let's see if we can get there. I have a question for you guys here. Why do I have request timeout first before I get in reply, before getting the reply?
Can you hear me?
Why the first request timeout? Why request timeout first before the replies?
The time to, can you hear me, sir? Can I?
I can hear you, sir.
All right, so I believe this is time to leave is not enough since it doesn't know the total ops it's supposed to do the first time. So probably the next time 313 are given the appropriate time to leave, or probably the up count in order to get to the destination.
Okay, any other person? Okay, who finished talking to me right now? Who talked now?
It's Ahmed.
Class rep, okay. Can any other person help us?
No, I just think it's correct.
Okay, any other person? Okay, so let's save time. Let me talk about it briefly. I'm sure you guys have done address resolution protocol.
Yes.
For any computer to talk to another computer somewhere, it must have your IP address and your MAC address in the hub table. The reason why you lose the first ping most of the time is because that computer has the IP address, because you're trying to ping the IP address, but it doesn't have the MAC address of that IP address. So it sends a broadcast. Hello, everybody on this network. I am trying to talk to this person with this IP address. If you are the owner, reply back with your MAC address. That's the reason for the timeout. It's not about hop now. Even as long as you are trying, even locally it happens. If I just drop a switch now and connect computers to it, ideal thing before we can talk to ourselves is I must know your IP address, I must know your MAC address. All the computers, no router. So this has gotten nothing to do with hops. It's all about hop request. Hop request. I have your IP address. Excuse me, I'm looking for your MAC address. Let me show you the table. I think it's hub-A. Good. This guy he can talk to our router. This is the MAC address of the router. He can talk to this .4 now. This is MAC address of .4. Who is .4? The other customer. Now I don't have .3 here. So why I don't like using packet tracer to demonstrate this thing is sometimes this thing misbehaves. It doesn't really work the way it's expected. But that is the ideal thing in the real world. Before you can talk to me as a computer, you need to know my MAC address. You need to know my IP address. If you don't know it, you send hop request. That is the reason for losing that first packet. You see that the subsequent packet will go because right now, the computer now knows your details. If I go back to that hop table, it's supposed to show us, okay, I think I know why it's not showing me that .3. Okay, I'm pinging 101. Oh, I understand. Now, this 101 is on the other segment. I am passing through the router. But locally, it's showing me 100.4, 101.1. Now I also have 100.3. Now that I ping 100.3, now if I go back to that hub table now, I'm supposed to have .3. So that's why I don't like demonstrating this with packet tracer because sometimes it doesn't give me what I'm looking for. But in the real world scenario, even if you drop a switch and network computers to it, you get the timeout if they have not been able to get their combination of the layer 2 address and layer 3 address because these things have to be mapped together. You talk about the header, frame header, packet header. All these details have to be completed before we can talk. That's the reason why you lose that. Somebody's distracting us there. Hello, Prof. Hello, Prof.
Yes, it's not.
You can mute the person on your own side.
I don't know who is doing that because we have more than. I think we have other people in the class too. So please, if you need to, you are what?
I said I have 2 instances in the class, but it's not any of them that made the.
Okay.
Let me check.
Okay.
Let's mute ourselves.
Everybody's on mute.
Please, if you need to talk to make calls or whatever, mute yourself because it breaks my flow from here. It breaks my flow. So you need to help us out. If you need to make calls or do something quickly, and please try to concentrate because before you blink now, we have done something and you will not know where we are. So we need to try to concentrate. That is the advantage of online training. When people are not flowing with you, you don't even know because you're not. The camera is not on, I'm displaying this on the screen. So please let's try to concentrate so we don't waste time unnecessarily. Okay, so the reason for losing that first packet is not because of anything hop count. No, it has nothing to do with hop count. TTL is different. When you talk about routing protocols and stuff like that, when you talk about time to leave, as the packet is going through different, is reducing the numbers of hop it has gone through already. That's a different thing entirely. But in this context now, the reason why you lose the first packet, sometimes the first 2, is because the computer is trying to get the MAC address of the system he wants to talk to, and he has to send brokers out quickly and get it, and then you now see reply with subsequent stuff. Now, the point I'm trying to make here is this. We have not done any configuration on our switch, and yet the computers that are plugged to the switches can ping. They can talk to themselves. They can go out of their network. So now I said that to say this. Your switch can work as plug and play, even though it is a managed switch. When you say managed switch, it simply means it's a switch you can configure. There are switches that are not managed switches. You can't do anything. The way you bought them is the way you use them. Just plug them to the network and that's it. We don't advise that for big organization. That probably can work for small organization, even though we notice big organizations also use this kind of switch. And if you use a switch that is not managed, What we are going to be doing tomorrow, you can't do it. We're going to be doing VLAN, you can't be doing interVLAN routing. We're going to be talking about port security. You can't do all those things. You don't have that kind of capability. So your switch and work as plug and play, and then you can manage it, you can configure it. So now I want us to configure this switch now and see something. Without it being configured, it's working. So why do we need to configure the switch with an IP address? Why do we need to give the switch an IP address? Let's assume I am somewhere within the campus and they complain to me about a particular location on campus that these people are not browsing something. Do you have to go to server room to enter the switch? You don't have to. It doesn't matter where you are, you can just have a remote access into that device, regardless of your location, as long as you are within that environment. As a matter of fact, if you are outside, if you have public IP address on the switch or port forwarding configured on the router, you can access any of your devices anywhere. So it is for management purpose. That is why we configure our switch. But for router, the router doesn't work as plug and play. It's a layer 3 device. It must have an IP address. The switch is a layer 2 device. It doesn't need IP address to work. As a matter of fact, the computers that are together on the switch talking to themselves, they only use MAC addresses to locate themselves, which is in the MAC address table. Just a minute, please. Sorry. So the switch can work as plug and play. It's a layer 2 device. It does not have an IP address. But if we should make mistake of not giving the switch an IP address, when we need to manage the switch remotely, then we're in trouble. That is why we give the switch an IP address. Now, there's a difference between the way we give the switch an IP address and the way we give the router an IP address. For the router, we put the IP address on the interface. But for the switch, we put the IP address, or let me say for the router, we put the IP address on physical interface. But for the switch, we put the IP address on a logical interface, not physical interface, logical interface. So what do I do to configure this switch? I can use the same computer we used before, or I can bring in another computer. So let me use the same computer, yank up this cable, bring it to the switch, connect to the console. Same thing we did. If I hit enter, let me see the connection. I put it on the wrong port. Let me carry another computer. This is not responding for some reason. Okay, I think I have an idea. Let me go and change my settings. Remember we said for a switch is hardware. I don't know, I think that's the reason. So now I'm in a switch. Take note of something here. The router asks us if we want to enter the initial configuration dialog box. The switch won't ask you that kind of question because by default, the switch can work as plug and play. The similar things we did for our router, we're going to do for the switch. Like what? That phase 1. So I'm going to just move fast. Go to global privilege mode. Give the switch a name. host name, say SW1, line console 0, password, say Cisco, login. Then I can say enable secrets, let's say class. I'm done with phase 1. So what do I do next? I want to give this switch an IP address. Watch out. The switch has physical interfaces. Look at them here. What's that command? Show. Do show now. Do show. Let me go to privilege mode. Show interfaces. Let me get brief command. This one will be it will be cumbersome. Show interfaces. What now? It should be brief. Status, yeah. Look at all the interfaces I have on my switch. Plenty interfaces. I am not putting my IP address on any of the physical ports. I am putting it on a logical port that all these ports can relate to. How do we access that logical port? I will go to global configuration mode, interface VLAN 1. Take note, interface VLAN 1. VLAN 1 is a logical interface, not physical interface. I'll hit enter. My prompt is the same here. So what do I want to do? I want to give my switch an IP address. I'll say IP address 192.168.100.2. Remember, this is the switch that connects to LAN A. Then subnet mask 255.255.255.0. I hit enter. I say no shots. And guess what? I'm done. But this is not the end. We gave our computers IP addresses. We gave them subnet mask. We also told them about default gateway. The switch also needs to know about default gateway. If not, the switch will have an IP address, but you can't enter that switch from in different segments on the network. You must be in that LAN. But if you want it belong to another LAN, you can't enter. So how do we do that? We exit and say IP default gateway. Then we tell the switch about the gateway, which is 192.168.100.1. No need for any subnet mask. We hit enter. And guess what? We are done. I get out. I save my job. Show history. Let's see the list of the commands that I just issued now. Oh, it won't show me the others. So I gave my computer's name, the switch a name. I gave the switch put password on line console 0, put password on privilege mode. Don't forget we have not touched line V2Y. I'm going to do that after break. We take like our 15 minutes break. Then what happened? Show IP interface brief. Show IP interface. I think so. Look at the IP address we put on our interface, on our logical interface. And we told the switch about the gateway. Show running config. Can see what we have in our running configuration file. Look at all the things we have here. Look at them here. These are different things we have. We'll do the same thing for the second switch before we now talk about terminals. And then we can continue with our story. So let's go to the second switch. So the second switch, instead of me consoling, just to save time, I can just click it. Let me break the rule here. Go there. So this is switch B. Host name or switch 2, SW2. Then line console 0. Password, Cisco. Then login. Then exit. Enable secrets. Class. What next? Interface VLAN 1. So what do I want to do? IP address. Don't forget this switch belongs to the other side. 192.168.101.2. Then 255.255.255.0. And then we'll say no shots. And then we'll get out and also tell this switch about default gateway. IP default gateway 192.168.101.1. Get out here, go to privilege mode, save your job. We're done with the switch also. Am I communicating? Are we together?
Yes, you are. Yes.
Hello,
Yes, I can hear you. Can you hear me?
I can hear you. Sorry, I want to just ask about you from saving the running configuration. What's it called, on to the startup? You use WR. You use WR. What's the full? Because what we know is like what I know is like copy run, this and that. But yeah, I can see WR.
It's like you came in late to the class.
Of course, yes, sir.
I explained that one before. That's an old command. It's
The WR?
right. Yeah, WR is right.
Okay.
It will do the same thing as your copy running config, then startup config.
Yes.
It's old command.
Okay.
Yes, exactly, sir.
Yes, it's clear, sir. Thanks, sir.
You're welcome. Any other question, please? I want to take care of the telnet section before we go on break. So we know that when we come back, we're just going to continue with our stories. Any other question? Can we proceed? Are we flowing together? Please, you need to respond.
Go ahead, please. Go ahead, please.
Yes.
Sorry, Mr. Roland.
Yes, sir.
From the this configuration of switch, like the VLAN, you say it's a logical configuration.
Interface.
It's a logical
Logical
interface.
interface. Yes.
Okay, but like when we were doing the CCNA 1,
Yes, sir.
it was mentioned there that the topology will have from the topology will have the logical and the physical configurations or interfaces. There, where this it was also mentioned that when we are configuring our interfaces, they are configured logically. But here you mentioned that the switch, they are logically being configured. Why this router is like those interfaces should be configured maybe physically. I don't know whether I got what you said then right.
I'm not getting your question right. Okay, let me
Okay.
just explain myself. When you want to
Okay,
assign
sir.
an IP address to the switch,
Yes, sir.
you know the switch has multiple ports, like 12
Yeah.
ports, 24 ports. You
24
don't say,
depends.
depends on her. You don't say interface, let's say facet and 0/1. If you do that, that means you are entering that port physically.
Okay.
There are multiple ports on the switch. It's like a router now. You could get a router of 4 ports.
Yes, sir.
For Cisco routers. For non-Cisco routers, I've seen the one of 24 ports. 24 ports. That's the 24 port on the non-Cisco router. I can use it to segment my network into 24 different segments, like different departments. And each of the departments will have an IP address on that interface. But the switch that will be connected to that department, if I want to give an IP address to that switch, it's not going to be on a physical port. It's going to be on the logical port for the switch. You don't put IP address on the physical interface of a layer 2 switch, except a multi-layer switch, which is a layer 3 switch. We now use it like a router. But as long as we are talking about layer 2 switch, the IP address is put on layer 2 on a logical interface. I don't know if my explanation is clear to you, sir.
Yeah, yes, sir. It's clear.
Any other question, please? Any other question? Okay, so if there's no question, let's conclude on this. Now we have done our configuration. So let's see if these computers can ping the switch. We gave the switch an IP address. Let's see if they can ping the switch. Ping 192.168.100.2. My switch is .2. Can this computer ping this switch? Same thing I told you guys about HAP is what just happened here. The computer can ping switch 2. That means if I need to enter switch 2 right now from this computer, remote access, not passing through the console. When you pass through the console, it means you are with that device physically. As long as I can ping that device, ping is a layer 3 thing. As long as I can ping that device, I can have a remote access into that device. For instance, now, this switch now, I can ping it. That means my layer 3 is okay. If I want to have a remote access using telnet, that's a layer 7 issue. So let's try to enter this switch remotely. We are not pinging now. We want to access the switch. I will say telnet 192.168.100.2. Watch out. He said he tried, but he couldn't get there. Why couldn't he get there? We didn't configure line VTY for our switch. The same thing with the router. I can ping the router. Ping 192.168.100.1. We can ping the router. Let me try to enter into that router. Telnet 192.168.100.1. It can't go. Why? We did not configure line VTY. So if you know that you are not going to have a remote access at all, you leave this out. But for the purpose of ease or flexibility, for you to be able to manage your devices remotely, it's not enough for you to just put IP address on your switch. You must put on the router, but you must also configure your telnet session or activate the telnet session. So let's start from the router. Now I'll just be clicking the devices. If I click this router right now, go to my command line. Watch what is going to happen now. So now I want to configure for VTY line, meaning this router, I want to prepare you for remote access so that when next I'm coming in, I can access you remotely. So how will I do that? I'll go to global configuration mode and say line VTY. This is for remote access, not physical access.
Your line is linked. It's not line, sir. You can check the spelling.
Okay, yeah, thank you. It will have rejected it. So line VTY. This is for remote logging. And there are plenty. For router, at least 5 terminal lines. I can decide to just do only one. If I know that there are 5 of us that will be managing the router, I can say 0 to 4. As a matter of fact, I think they increase that in here. See now on the router, I can say that this router has 1 to 15. In the old ones, they are 0 to 4. So if I know that I'm the only one that want to be accessing this router remotely, I will only configure for line VTY 1. Back in those days was line VTY 0. 0 should still work. Let me see. 0 worked now, but they gave us the range. So I can just say line VTY 0. But mind you, you can configure different lines with different passwords. So if I know that there are 10 people that will be managing this router remotely, I will give them different passwords. So you know your password when you are telnetting into the router. You have a different password for your privilege. I mean, for your users mode. So for me, I'll just do only one. So let's say the password is Cisco 123. I wanted to show you guys something. I will show you when we get to the switch. If I like, I can just activate this VTY line without password, but that's not advisable. So I'll say line VTY. I will hit enter. It will still bring you to config line here. And then you now have password Cisco 123. If you stop there and you don't put login, it's not going to work. So you say login. Guess what? We have configured VTY line for our router. Let's test if it's going to work. Back to that same computer we're trying to use to telnet into our router. If I bring out the command telnet 192.168.100.1. I am saying give me remote access into this router. If I hit enter right now, it's asking me for password because we have configured that router for remote access. And the password is Cisco 123. Guess what? I am now in my router. So I am not in the server room. It doesn't matter where I am on campus. I'm in somebody's office. They just call me. Something like this happening, and you want to quickly enter into your router. You have configured your router for remote access. You just telnet. Now, this password is different. So now we have two different passwords to enter into our router for users mode. One is Cisco. The other one is Cisco 123. It depends on where you are coming from. If you access the router through console port, you use Cisco. That means you're in the server room physically connecting to the router. But you have, if you are passing through the spirit realm to access your router, meaning you are not there physically and you still want to access the router, you use the password for line VTY. Both password will give you, I'm coming Ahmed, both password will give you access to users mode, but it depends on where you're coming from. Yes, Ahmed, you have the floor. Ahmed.
Okay, so I'm just reminding you about the time.
Okay, it's time for break.
Yeah.
Okay, just give me a few minutes. Let me finish with the switch so that we're done with this. Thank you. So now let's quickly go to the switch and then we go on break. So if I go to this switch right now, this switch also we see that we couldn't telnet into the switch. So let's go to the switch. So go to global configuration mode and say line VTY. So the switch also has 15 also, yeah. Let's just pick 0. Hit enter. If I just say login now, watch what is going to happen. I didn't put password, meaning anybody can get a link into my switch. Login, disable online 1 until password is before it wasn't like this. So they are trying to force me to put password. Before you can just put login, then you can have that, you can enter that device. But this one, they are not going to allow me. This is good. So let's just put it. Let's see Cisco 123. Then we can now say login. So if I go back right now to my computer, now guess what? Watch something new. I am inside my router here. I can from my router telnet into the switch. I can go from one device to another device, another device, another device. I'm just moving in between devices. So let me go to enable. What's password for our privilege modes? No class. Oh. Okay, class 1. I think I remember. Good. So from here now, I can telnet 192.168.100.2. Can you see what I'm doing? I am inside the router. I am from the router entering the switch. You see what we are doing here? So when I'm done from this switch, by the time I get out, it dropped me back into my router. By the time I get out on the router, it dropped me into the laptop where I'm coming from. So all of these things you need to activate for remote access. It will help you to do your job. It will simplify the way you do your work. So you don't have to move in physically into the server room and so on and so forth. Any question, please? Do we have any question on this? Are we good? Okay. If you don't have question, we're taking how many minutes break? How many did we agree? Is it 15 or 20 minutes?
I think 20 or 30 minutes. I don't know about the rest.
Prof, is Prof still there?
Ahmed, where are you going to?
Let's take 20 minutes. 20 minutes is okay. Because we still have a long way to go today. I didn't even know it. I didn't know it would take time like this for this recap for its configuration. But I hope you people are happy that we are doing a recap.
It's good.
Yeah. It's okay. So let's meet. This is 11:03 here. Let's meet by the, let's say 11:23 or 11:25.
Okay.
Thank you.
Thank you.
Welcome.
Thank you.
Thank you.
Hello.
Yes, I can hear you.
Are we all back?
Yes, I believe we can start.
Let's confirm, please. Mr. Taiwo, are you there? Thumbs up if you are there. Mr. Amotayo, are you there? Thumbs up. Prof. Hello. Mr. Ahmed, can you help us get in touch with the rest? Let them come in. The break is over.
They are were physically apart, so there's no possible way I can.
Call.
I
Can you call
saw
them on
someone and
WhatsApp?
I told him we're about to start, and he said, okay. So either we wait for some 5 minutes and let them come back, or we just continue. So we can probably add 5 minutes to the waiting time then.
Okay.
I'm here. I'm here. It's just that my screen went off. So
Okay.
you don't have to add. Everybody should be here, and we will start.
Okay, so can we continue?
Yes, I think
Yes.
we can, because I've just seen Professor Shiga and Dr. Kwemi, and they are connected. I was here when you were asking him. I don't know
Okay,
what's
sir.
wrong with the screen.
Okay, so let's continue. So we are supposed to go back to the story, but let me talk about SSH briefly. I have demonstrated the use of Telnet. But you are always advised not to use Telnet because Telnet is not secure. Anybody can come in between your device, any of your devices, and capture all your commands or communication with your device and be able to decode all those things. So you are advised not to use Telnet. Instead, you use SSH. What is SSH? SSH is basically Telnet encrypted. It's just an encrypted remote access to your device. So you need to learn to prepare your device for remote access, either your router or your switch. So I will just show you guys how to do that. I am trying to see how I can SSH into the device. I can't remember the command, so I'm going to try to check it out. And tomorrow I will show you guys how to SSH from packet tracer. I'm talking packet tracer now. In the real world, you use PuTTY, and that's not a problem. So I'll show you how to do that and put it too. So I'm into my router. I believe you can see my screen.
Yes.
So how do I prepare this router to support SSH? Very simple. At global configuration mode, I need to put up some commands. So number one thing is, the first thing you do is you create a database for the users. We don't use the regular line console or line VTY stuff. We create a database. And this database, you have username, password for different users, depending on the person you want to give access into your to SSH into your router. So the command to create the username is username, or the users is username. Let's assume I'm the first user here, Roland. Then instead of saying password, I can just say secret. Why would I want to say secret straight away? Because we know that this is encrypted. That's MD5. So let me say Cisco 1 or user 1. That's my user, that's my password, user 1. I can have other users, maybe username, prof, secrets, whatever, username, another person. So you can have multiple users in this database. So this is the first thing you need to do in order to prepare your device for SSH. The second thing you need to do is to create a domain name. Maybe you say IP domain name Nile dot maybe dot edu dot ng. That's at global configuration mode. The third thing you need to do is to generate a key. That is like they call it crypto key, RSA crypto key. That's the router, the device, and the computer will be using to encrypt whatever communication is going on between them. And the command is crypto key. I think it's RSA. No, it's generate RSA. Crypto key generate RSA. Now, when you hit enter, what happened? It will tell you, ask you how many key, because you can increase the key. How do they put it? Like the algorithm they call with the key combination, you can increase it. So this is the default 512. If I want to have 1024, I can increase it. The higher the numbers of the key combination, the more powerful your encryption. But then it's going to put pressure on your device. So we can accept this basic one. So these are the three basic things you need to do at global configuration mode. You create the database, you give a domain name, you generate the key that the device will be using to encrypt whatever it needs to encrypt. Then the next thing, which is going to be the last, is now to go to line VTY. Remember, that's where we do our telnet before. Go to line VTY. Now that I'm in line VTY, it's trying to tell me something here. I now can say, I want to accept inputs from, do I only want to give access to SSH or telnet and SSH or any protocol? So I can decide to say all I want to be done, all I want access, anything that has to do with remote access on this my device must be SSH. It must be SSH because that is good for your security. So I will say transport input SSH. I will hit enter. Transport input SSH. Then the last thing is to say login local. What are we saying login local? The other time we did our line VTY, we just said login because we are referring to the name we put for our line VTY. We just say login. But this time around, we have to say login local. Why are we saying login local? We are making reference to this local database that we are creating right now, where we have Roland as a user and then the password as user 1. So we have to tell our line VTY, forget about that line VTY, all the details you've been using for telnet. Make use of the local database now. And now hit enter. And guess what? I'm done setting up my device for SSH. So I now need to go to my device, let's say my computer right now. This is what I've been trying to do during the break. I couldn't remember the command. And say, okay, I want to SSH dash, I think dash health admin, is it administrator? So then the IP address of the router. Oh, my router is .1. Oh, beautiful, it worked. SSH dash health. I think I was trying to SSH into the switch, and that has not been configured for SSH. SSH dash health administrator 192.168.100.1. So my username is user 1. Sorry, my password is user 1. So it's asking me for the password, user 1. What's that, my password, user? Let me check my password again. Yeah, it's user 1. Why is it not taking it? Okay. Something should have missed me. I think it's case sensitive. Let me see. Okay, it's on. Oh, Is it? I need to put my username. I can't remember this. So I will check this in out and then demonstrate for you guys tomorrow. I will complete this part tomorrow. So it's still the same topology. I'm not going to remove it just to complete this. So basically, the difference between what we are trying to do now and what we did before, Telnet is not secure. SSH is secure. So you need to know how to prepare your device to support SSH. So that when you want to do remote login, you don't ever use Telnet. You use SSH. Let me log in and show you. I don't know why this put in. Okay, so if you want, look at putting here. You can see SSH here, and you can also see Telnet here. So if it's SSH I want to do, I don't need Telnet. I will select SSH, then put the IP address on my device. And SSH runs on port 22. Telnet runs on port 23. And then I will enter. So whatever I'm doing with my device remotely, regardless of where I am, everything is encrypted. So that is why you are not supposed to use Telnet. You need to have a remote, secure remote access to your device wherever you are. So that is what I want to show you guys on this one. Any question before we proceed? So I still have a lot of things to show you guys. So we need to talk about a few commands that you need to be aware of or familiar with. So we have to go to those commands one after the other. We've used some already, like show running config. We've used the command. You need to know what you are looking for. Show running config. You see the configuration file on your router. And this same command works on the switch also. Show running config shows you the running configuration file. You can also do show startup config. Shows you the backup configuration file. You need to be aware of this command. You can say show IP interface brief. You can see all the IP addresses I have configured on my router. On G0/0, you can see what I have there. See what I have there. Look at the ID of the router, because sometimes you are confused. Did I put IP address? Did I not put IP address? You go and confirm. See my G0/0, G0/1. Look at the IP address. Now, this part is very important to us. Under status, you have up. Under protocol, you have up. Why do I need up? Or why must I always see up? Look at the G0/2 here. It doesn't have an IP address. Look at status. It's telling me administratively done. Why? Anytime you see administratively done, it simply means that interface has not been activated. I can go to this interface right now without any IP address, as long as I have something connected to it, and just say no shutdown. It's going to show me hub, but it will not have an IP address. Coming back to this one here, why do you must always see two ups when you are troubleshooting? The first one has to do with layer 1. The second one has to do with layer 2. The interface must be activated and must be hub. And the line protocol must be hub. Line protocol has to do with the connection. If, for instance, now I unplug a cable from the interface of the router, the interface will still show hub, but the line protocol will go down. Meaning layer 1 is okay. Things that has to do with layer 2, there's a problem there. So anytime you are troubleshooting, I can't ping. Why am I not pinging? Show IP interface group. Confirm that you have an IP address. Confirm that the status is the layer 1 is up. Confirm that layer 2 is up. These are things that we do to do our these are commands we put in to do our troubleshooting. Which other command is there? You may decide to go and check interface by interface for whatever reason, depending on what you are looking for. I can say show interface G0/0. I don't want to see all the interfaces. I just want to see G0/0. I hit enter. It's going to give me a lot of detail about that interface. You can see the interface here. This is my G0/0 interface. The interface is up. Line protocol is up. This is the MAC address of the interface. Look at the description on the interface. Look at the IP address on the interface. This interface is running full duplex and it's 100 megabit per second. And the media type is RJ4. So you get more details about this interface. So you need to be familiar with different commands. So as you proceed in the training, you're going to get used to most of these commands. As you proceed, you will get used to. So I can decide to just check one interface. If it's running half duplex and I'm suspecting that I'm having problems, I may want to check input errors. Input errors are something like accident or collision occurring. I may want to check all of those places. So these are some of the commands I can remember. So let's go back to the PowerPoint and then see what we got left as far as storage is concerned here. So I'm going to be running very fast. So look at different commands that you can have here. And you need to know, oh, yeah, I was going to talk about this. Let me see if I have any other thing behind before I talk about this. So I've talked about full duplex briefly. It has to do with, I talked about half duplex before. Then the full duplex is where you have dedicated part for going and dedicated part for coming. So you don't have a limitation, or you are not limited to having what you call it, collision again. Nowadays, everything we use now run on full duplex. So we have full duplex communication. And that means every computer has a dedicated connection to the switch to send and to receive. Sorry. So every computer has a dedicated connection to the switch. Unlike the days of half duplex, you don't have a dedicated connection. You don't have a dedicated connection. So nowadays, we don't have half duplex again. All we operate on is on full duplex. It simply means we can transmit and receive simultaneously. And because of that, we can double our bandwidth. When I say double our bandwidth, I can use 10 meg to send. I can use 10 meg to receive. So on that same port, 10 meg to send, 10 meg to receive. That is how full duplex operates. And that is what you got right now. And back in those days, you may have to set the speed, the duplex, or you set the speed. Later on, they came up with some switches that can automatically detect that my neighbor, the person that is connected to me, is running on half duplex. I come to your level. If you are running on 10 meg, I come to your level. So that is why they advise you to leave the configuration of the switch. The interface is on auto negotiation. Do not change it to manual. Manual means you want to change, you want to set the speed by yourself, or you want to set the duplex by yourself. No, it's not advisable. You will meet it on auto. These are whole stuff. Leave it at auto. But nowadays, those switches don't run half duplex again, so we don't even need all of these things again. So let's assume you want to change this thing manually. You enter the interface and say duplex full. Or you want to change the speed, you say the speed 100. You have turned these things to manual. So what are you supposed to do? You are supposed to leave them on auto. Because if one side is running half duplex and the other side is running full duplex, and you have forced one of the interfaces to run on full duplex and the other one is on half duplex, there's going to be collision. And those collisions will result into a lot of things called runs, like broken packets, packet loss, so many errors that you're going to be having. So let's talk about Octo MDIS. So what is Octo MDIS? When automatic medium dependent interface crossover is enabled, that is the full meaning of Octo MDIS. I talked about when you use the so-called run cable in quotes and things will work. This is the reason why it works. Where I'm supposed to use straight through cable, if I go and use crossover, it will work if Auto MDIS is working on my switch and on the computer. Where I'm supposed to use crossover and I go and use straight to it will work if Auto MDIS is working. So what this thing does basically is to logically change the connections at both ends. So if it's supposed to be crossover and I'm using straight through, it will rearrange it logically to make it look like it's crossover. As the same thing applies to your straight through cable. But if your device does not support Auto MDIS or it supports it is not enabled, you use the wrong cable, it's not going to work. So you must always make sure that the device supports it and that feature is also enabled. Everything just set to auto. Activate the technology and leave everything to auto, and you are good to go. Those things come with auto by default, and you are good to go. Look at all the models of Cisco switches that have all of these things enabled from and above, 2960 and above, Catalyst 3560. But there are some of the old ones, they don't have these things. So if I go and carry 2960, 2950 series switch right now and plug my laptop to it, and I'm supposed to use through and I use crossover, it's not going to work because it doesn't support up to MDIS. Same thing applies to 3550 series. You need to be aware of this. Okay. To examine the auto MDI settings for a specific interface, so you can check, use show controller Ethernet controller command with the file keyword. You can limit it. You used to include command can limit. So let's assume I want to confirm. Is it even enabled? You can decide to tailor down or narrow down your output to a particular interface. But the most important thing is make sure the device supports that before you try to enable. So these are the show commands we need to learn. You can you can say show interface, you narrow it down to a particular interface, show startup config, show running config, show flash and version. Very important. I'm going to show those ones for you. Of course, when we come to the switch, we are going to check show MAC address table. Show interface, I've showed you guys this. What do I get from show flash? I need to see the version of the operating system I'm running, or the location of the operating system, or let me say the directory. And of course, the version will show me the version of the OS that I have running on my device. So let me show you guys. Back to my router. So let's say show version. So what's my takeaway from this place? So many information here. I can see the image. Look at the image that I'm running here, the image on this router, and it's inside flash. So you see it under system image file. I can see how long this router has been powered. The model of the router, 2911 series, and how long it's been powered. Look at it here. Beyond that, I can see other information, like what? Configuration register. I'm going to talk about that. I don't know where. Configuration register. Very important. I can even see the what do you call it? The license that was enabled with this operating system, because this operating system can support IP, security, UC, data, but they only activated the one for IP. That is the base activation. These are outputs you get from show version. So most important, most of the time we come to use show version command is to see the configuration file or to see the version of the operating system running. Another one is show flash. Don't forget that is where we have our operating system running. So you can see the output of the flash here. So we still have the OS here showing us here. The size of the OS. No, that is the size of the flash rather. This is the total size of the flash. This is the total here. This is what is available. This is what is in use. So what do we normally come and look for here? Let's say I want to upload another operating system. Do I have enough space in my flash to take the new operating system? If I don't, then I cannot upload another operating system. So these are different show commands. So you get used to the show commands as we proceed. So we've taken care of this show run. You can see so many things there. You can tailor down your to see the interface, show interface. Then you put the detail of the interface. Then things that has to do with network layer issue, like I talked about, maybe layer 1 and layer 2. What about layer 3? Does the interface have an IP address? You can see from show interface, or if is the interface up or the interface is down. Those are things you get from the output of show interface command. But narrow it down to the particular interface. And of course, if you are running on, do I say, half duplex, you have to be concerned with runs and giants and input error, or even the CRS, cyclic redundancy check, especially these input errors. This was in the days of half duplex. Nowadays, you cannot have anything like this again because we run full duplex. So what are all these input errors, runs, giant, and the rest of them? These are old stuff. For me, I don't know why they are still in the curriculum because these are things that are applicable to half duplex. But for full duplex, you cannot have all of these things again. So in summary, when your packet is get messed up along the line, maybe as a result of collision, the two packets collided, or the link is bad, the cable is bad, the network interface is bad. These packets comes in some are maybe like in chunks, small chunks. The waves are distorted. That is just the right way to put it. So some of them are called runs, some of them are called giant. Giant is a bigger packet, it's bigger than the way it's supposed to be. The runs are like the small ones. And when you have CRS error, it's like I have sent something to you and I told you this is the size, total size. By the time you got it, it's not up to that. That is your CRS error. So these are problems you encounter when you are when you're on half duplex. And you can check all of this output from showed interfaces. But this was back in the days of half duplex. Full duplex, you can't have all these problems again. So of course, collision is also there for half duplex, either the regular collision or delayed collision. And what is collision? If you guys talked about broadcast domain and collision domain in CCNA1, you realize that. Did you people talk about broadcast domain and collision domain? It's supposed to be in CCNA1. Let me be sure. Hello, sir. Prof.
We did. I don't
Okay,
know why.
beautiful.
Yes, we did.
Okay, beautiful. So when you have collision, the only reason why you can have collision is because you are running on half duplex. But if you are running on full duplex, you can't have collision. So the collision can be in a normal collision, which means I am sending, you are sending, and because it's one-way traffic, we collided. And what's going to happen? That particular link is not going to work for a period of time. And sometimes you can have what is referred to as a late collision. I assume everything went on fine and it got up in collision. So these are some of the things you need to get to know about network access layer issue where we use our showed interface command. Now, let me tell you this. Showed interface command doesn't just give you network access layer issue. It gives you layer 1, it gives you layer 2, it also gives you layer 3 issue. So we are just trying to be particular about this part has to do with network layer. Some of this output have to do with network layer. And of course, here they talk more about these run frames. These are frames that are shorter than 64 bytes. The minimum frame size should be 64 bytes. Anything lower than 64 bytes, it is called runs. And of course, we have the ones that are called giants. So they are bigger than, I think, 1500 or so. 1500, that should be the maximum size of frame. If it's bigger than that, they are called giant. And of course, you can get involved in, you can also get CRS error. Once you have runs, of course, you are going to get CRS error. Things will not go normal because the message is messed up it's been messed up along the line. And this could be as a result of damaged cable, damaged network card, or too much noise on the link, even though this noise is inconsequential if you use a very good cable. And as long as you're not running on half duplex, you're good to go. So these are all the explanations. So late collision can happen because of half duplex. This is normal. But when you talk about late collision, it's on half duplex also, but I assume everything went on fine. So we're not going to waste time on this one. So I've talked about the network layer access issue, layer 1, layer 2, layer 3. You need to know how to troubleshoot. And we're still going to talk about that. What if I can ping? What are the things I need to look at? And most of the times for layer 3 is IP address. It's either there is no IP address or the IP address is wrong, or the IP address is correct, the subnet mask is wrong, or the subnet mask is correct, but the default gateway is wrong. Anything that has to do with IP address those are layer 3 issues. And then of course I've demonstrated remote access where you can use your telnet operate on port 23. And of course, if anything is captured, you can see your username and password if you are using a local database. And even if you are not using a local database, you can see if your conversation is captured with Wireshark, everything can be seen. So you're not supposed to use telnet. You should use SSH. If you use SSH and things are captured, this is the way it will be displayed. they cannot make sense of what is captured. Why? Because SSH uses strong encryption, because we have to authenticate the users and then the password. And of course, we create an encryption key for the communication. This is how it looks like. So one thing, how do you verify that your switch or your router support SSH? From the output of this show version, you must see K9 from the OS. Look at the K9 here. Where is the K9 in this place? K9 here. Look at it. Remember, we went to our router, and right now with this show version, if you see K9, that means it's going to support SSH. If you don't see K9, it's not going to support SSH. You need to be aware of that. And then, of course, I've done the configuration. So the only thing I think I didn't mention is you can enable more than one version. As in, you can enable version 2. There is version 1, there is version 2. It's just in the encryption key or technology. Version 2 is more secure than version 1. But all the stories that are here, I have demonstrated them from the configuration to us.
Hello, sir.
Yep.
Sorry, you mentioned about the K9.
Yeah.
On the router, that is, if it's not enabled, can it be configured?
Not if it's not enabled. I'm saying the SSH must. I think you are missing two things together now.
No,
we must
what
set
I'm
up the
saying is,
device from you must set up the device to support SSH. But then, how do you know that device support SSH? You check the version of your operating system. Let's go back to our router. I said show version. Look at it here. It's not something you activate or deactivate. It comes with the OS.
Okay, it comes with the OS, with those, the MD5 and co.
Once the OS supports encryption or anything inside that's been put inside, your own is just to activate them. MD5, MD7, or whatever. It supports beyond what you can do. Now, if you see something here, let me show you something here. This OS that you see, the only license activated here is just IP. Tomorrow now we can talk to Cisco and say we want to start using this as a security device. They activate the security part, so more stuffs or capability will come alive in that operating system. That's called, they call it universal OS, universal iOS. In the time past, they have a different OS for security, different OS for voice, different OS for IP stuff. But now they put everything in one. You just pay for the license and you activate. But we're still saying even the base license support all of these things we are talking about, as long as you see K9 there. Is that clear? Hello, sir.
Yes, sir. Yes, sir. Thanks, sir.
All right, sir. Okay. So I've taken care of this. How do you put it? Practically, I've demonstrated this practically. So I still have one thing I need to show you guys, because I couldn't enter into that router. So I can see if I've activated SSH, or to see the version that is activated with show IP SSH command after activating it. And of course, you can see in this scenario right now, version 2 of the SSH is what we are running here. And so we have a packet tracer activity that you guys are supposed to do. I'm going to send that after the class today, before tomorrow. So this is what you are going to create: secure password. Yeah, I'm coming, Ahmed. Encrypt communication, and you verify the SSH implementation. Yes, Ahmed, go ahead.
All right, thank you, sir. I don't know if you've activated the
assessment. I've not even enrolled you guys.
And that's what I meant by the question.
I will do it after the class today. I will enroll you guys and then activate.
Okay.
Thank you. So, all the basic router configuration, we've taken care of all of this is practically. It's just the show command. I just mentioned banner MOTD. I didn't configure it. So you can also do that. Running config, copy running config, startup config. I talked about that. You can have dual stack. Anytime you hear that stack, it simply means you are combining both IP version 4 and IP version 6 in one network. And why would you want to do that? You want to do migration gradually into IP version 6. So you want to find out if things will be broken on IPv4 when you yank it off. If you yank it off and you see that the 6 is working perfectly, then you retain your 6. That is the reason why you do that. So I've done all the configuration of the router. That's the best way I do this particular chapter. I do it practically. Activate the interface, put description commands. You can also put IPv6. I'm sure you guys did IPv6 also. We're going to make use of that in, I think, chapter 8 or so. You can also put enable loopback address. I need to talk briefly about loopback address. Maybe this is what somebody was trying to ask me earlier. On my router, I can decide not to use a physical interface if I like for some reason, and go and use what we also call logical interface on the router. And those interfaces are referred to as loopback interface. For instance, now, let's say I have a router. This is my router. It has 2 ports. And I'm doing a lab. This is switch here, switch here. For my lab, I need 3 LANs, 3 local area networks. But there's no more, I don't have any other interface on my router. I can use my loopback interface to simulate a LAN logically. It's not there physically, but any IP address I put on that logical interface is assumed that it's on my local area network. So we use this to emulate networks behind the router. So if I drop a router right now, and I put one logical interface, another logical interface, another logical interface, and I'm doing all my lab, all my configuration, I can even have 10, 20, 30, it's in millions. It's as if I have 4 LANs, 10 LANs, 20 LANs, 30 LANs, and any configuration I want to do, I can do in between. That is one of the beauty of loopback interface. We use it to simulate a LAN behind the router, just to test some stuffs. And we also use this when we come to OSPF. When you do OSPF, you are going to see it, because this interface does not go down. And under OSPF doesn't need physical interface address to stay up. It prefers to use the loopback address. You're going to do OSPF in CCNA 3. That is the next person that will be coming to teach you guys. So loopback interface can be used because of OSPF, or we use it because we want to simulate a LAN or networks behind the router. That is when we make use of loopback interface. Just for more, we can use it for so many things, but it's not a physical interface. It's a logical interface. Let's assume I want to do imaginary pinging to the internet. I can use the loopback interface to do imaginary pinging. Just put an IP address there, do some configuration, and then I'm good to go. So take note of that. So we also have, I don't want to give you too many labs in this part, just maybe one lab for you guys to do 1 or 2 things. But when we get to the next class, that is tomorrow, VLAN, in VLAN routing, labs, non-negotiable. So we can verify directly connected networks. How do you verify that the networks are directly connected? We have done that already. We ping from our computer here, that is in one line A. And we went all the way to the computer that is in LAN B. That is a way to verify connectivity. Ping is to test for connectivity. But you may want to test from the router too. From the router, you can ping the computer. We can ping the computer. From the switch, I can ping the computers. Let's say this is, okay, this out. So you can ping the computers. So different ways to verify, but the easiest is to do end-to-end. End-to-end. Ping from one computer that is in one LAN to the other LAN. That is one of the ways you demonstrate connectivity. Okay, so we've talked about this command, but I didn't talk about this command, and I'm going to show you now. Show IP route. Why do I need show IP route command? If I want to start troubleshooting, I have issues, things are not working accurately. I want to see the networks that are directly connected to my router. Does he have those networks in the routing table? Because the routing table, we're going to talk more about that. And that will be when I come down. Routing table is like your GPS. Any network that I don't have in that table, I cannot reach that network. I cannot help you to reach the network. I can't bring that network. And if you are connected to me, expecting me to help you to reach that network, I can't reach the network. So I'm going to show you guys that. Let me just show you guys. So I want to check the routing table of my router now. Don't forget, the routing table is like our map. So I'll say show IP routes. But I prefer to put connected. I want to see the networks that are directly connected to you. You can see what we got in this place. Sure, God. I have C. What's the meaning of C? Directly connected network. It simply means 192.168.100.0/24 is directly connected on G0/0. I have another network directly connected 192.168.101.0 is directly connected on this interface. How did the router know? We put an IP address on those interfaces from this network, and the router can calculate and know where you came from, and that is the meaning of this L. This L is like the direct address. Let me show you some things here. You see, we put that .1 on one interface of 100, and then we put another .1 on another interface of 101. So what is the meaning of the L? What's the meaning of the C? We have a place to see all those meanings. You can see L means local, just for that interface. This is an IP address on this interface. And C means connected, directly connected. This is our routing table. If I'm going to Lagos right now, I need to find out, does this router know how to get to Lagos? If it doesn't have that network address I'm trying to reach in this routing table, this router cannot get to that network. It doesn't know how to get there. So that's the idea. So we use this a lot to do troubleshooting when things are not working properly. We want to verify. So I can check for IPv6 and I can check for IPv4. When we're checking for IPv4, we don't put IPv4. This interface actually show IP interface brief. This show IP version 6 interface brief. When I have a dual stack network, anytime I want to check anything on IPv6, I have to add that IPv6. I have to add the version of the operating system. I mean of the operating system, of the address to indicate that it is IPv6. So we're going to do more on IPv6. We have a whole chapter dedicated to IPv6. I think in chapter 8 or so. So this is another command. We're taking an interface. We want to get to know about the IPv6 details on that interface. So we're going to do more. I like this command too. I forgot to mention it. Show running config interface gigabit 0/0. I want to see what is in configuration file, but things that has to do with just this interface. It will just get it out for you. Everything configured on that interface. Let's check it out. We know we have G0/0, so let's check it out. Show running config interface. I don't know if package will support this. Oh, package that doesn't support it, but the live router will support it. So packet tracer doesn't support this. Anything that is not programmed into packet tracer is not, you are not going to be able to use it. But the good command can help you to just single out configuration on that interface. And then of course I've shown you the routing table, and you can check for IPv6 also. And we can filter. This is the only part I think I have not mastered because it came out much more later after we finished CCNA. The first time I got to know about this command, this set of commands, it was when I was preparing for my CCIA, and I didn't find it funny. So these are commands that help you to filter things out. Let's say I just want to see things that has to do with line V2Y. Do I need to use include or section or exclude? Those are the part I've not mastered personally. But the more you use these things, the more you master these commands. Or a command that begins with something. We should have some example there. Oh, they didn't give us example. So these are the commands that I have not mastered. Before, they were not supported by packet tracer, but right now, I think packet tracer support most of these commands. Let's say, for instance, now let me go to my router. Okay, that same show running config. I can pipe. You can see pipe there. Where is pipe here? Okay, see pipe here. Pipe, if I put question mark now, you see, I can use begin. I can use exclude. I can use include. I can use section. I think I mastered section. Let me say section. Section what now? I don't know. Support line V2I.
Check the LT line.
Oh, thank you.
That section.
So if it's not giving me any output, that means it's not. I'm not at the right place. Why am I using show IP route connected? I wanted to use show run. show running config pipe. Let's say section. So those are the things that I have not mastered personally. Section line VTY. Oh, this worked. You can see it just went and lifted everything that has to do with line VTY for me. So instead of me looking inside my running configuration file and say show running config and be looking for something, if you know how to filter, you're not going to be in a mess. You just know if you use section or include or exclude, you just filter that output and bring it to you. Same thing applies to the interfaces. It will just filter that thing and bring out to you. So these are things you master as you proceed in the feed. So it's going to be all for this chapter. Any question before we proceed? Prof, can we still do the second chapter that I have in mind for today? That one is not much. Doctor?
It's just that we were looking at 12:30.
Okay, so should we just start it? If we can't finish it, then we'll finish it tomorrow, or we should just wrap it up for today.
We can start it. We still have up till 12:30.
It's just some of the things you guys did before on switching concepts, the collision domain, brokers domain. Well, I'm not going to waste time on this.
I think it's just a full slide. We can just quickly rush through it.
Yeah, there are a few slides. Okay, so let's go through it. Switching concept. Of course, what do you need to know about your switch? Switch forwards frame. That's why it's called a layer 2 device. How does it really forward frame? It's because it builds a MAC address table. You must have discussed this already. So let's go through this. So you can look at, this is an example here. By the time computers are connected to the switch doesn't know that you are there. It only gets to know you are there when you send something. That's when it learns your MAC address. So what happens when you send something and it doesn't know about the destination MAC address also? It will flood everything. Hello, if you are the owner of this MAC address, please send your IP address. That doesn't mean the switch will still add you to the MAC address table because it only uses the source, or let me say the sender. When you send, that's when it registers you in the MAC address table. And when it puts you in the MAC address table, what does it really do? It puts your MAC address, puts the port you are plugged to. Your MAC address, where you're connected to. Your MAC address, where you're connected to. Why is it named this? So when next you want to send, it just look in the MAC address table, or we call it CAM table sometimes. Oh, this message is going to this person with this MAC address. Okay, where is this person plugged on me as a switch? If you are plugged in port 5, for instance, it will just send the message to port 5. This is what differentiates a switch from a hub. Hub cannot make decision, but the switch makes decision. And the way it does that is by building a MAC address table. So let's move. 2 times are associated with frame entering or leaving an interface. When the frame enter, the interface you pass through is called ingress. The one you exit out is called egress. A switch forwards based on the ingress interface and the destination MAC address. This is key. I need to check your destination MAC address and push you out from there. A switch uses its MAC address table to make forwarding decision. It simply means I don't have you in my MAC address table. I can't help. I just have to flood the message to everybody. If you are the owner of this message, carry your message. Take note, a switch will never allow traffic to be forwarded out the interface it receives the traffic. It simply means when I'm broadcasting, if I get the message from port 1, I will only send to all other ports. I'm not going to send back to this interview because I know the sender is from here. That is the way a switch operates. So how does it build in MAC address table? I've explained that. So what is the MAC address table? A switch will use the destination MAC address to determine the egress interface, where to push the data to, or the frame. Before a switch can make this decision, it must learn what interface the destination is located. A switch builds a MAC address table, also known as CAM, contract address memory table. Look at it there. By recording the source MAC address into the table, along with the port it was received, until you send, the switch doesn't know you are there. It needs to know, it can only learn about you when you are there. The switch learn and forward method, what does that mean? This switch uses a two-step process. Number one, it learns. What is it learning? It learns your source address and has the source mark if not in the table. If you're not in the MAC address table, it now has you. Watch out. It will set the timeout settings back to 5 minutes if source not in the table. It means if you are not already in the table, it will put you in the table and then have a timer. Why would the switch have a timer? It cannot assume that you are going to be there for life or for a very long time. So it has to keep on learning every 5 minutes. In case you have gone and another person is plugged there, it will not assume you are still there. Step 2, it forward. It's examine the destination MAC address. If the destination MAC address is in the MAC address table, it is forwarded out a specific port. If destination MAC address is not in the table, how will a switch operate? It flood out interfaces except the one it was received. I don't know about you. I send the message to everybody. There's a video in the curriculum. You can watch that video on the MAC address tables on connected switch. Switch forwarding methods. There are two different ways, major. I think there are 3 of them, how the switch can forward. One is called stall and forward. But stall and forward simply means as you are sending to me as a PC, this is PC here right now. I am the switch. I will collect everything first before I start sending. That is called stall and forward. But there's another way to forward, and it is preferred by Cisco switches. I can also do call-through switching, meaning as long as I know about the destination MAC address, I open the link to the other side. As you are sending and forwarding, as you are sending and forwarding, as you are sending and forwarding, that is called call-through switching. So your switch can either operate in one of these two use one of these two forwarding methods. So you can stall and forward, or it can do call-through. So for stall and forward, what is the benefit? It will check for error. It will buffer the message. Check for error simply mean like, is everything okay with this data I want to move? If things are not okay, it will send back to the source. This thing, there is a challenge with the CRS. So, but if everything is okay, it's using its buffer. That's like the memory rest locally. And it can use that memory also to adjust the rate at which it's sending to the destination. Because sometimes this happens, especially for some switches, where you have maybe 100 meg on an interface, 10 meg on another interface. This speed is not the same. So for stall and forward, it's good for this kind of switch. It knows how to forward between the 2 ports. I'll stall everything and I can move. But if it is called through, this is not going to work well for call through. So for stall and forward, it does error checking and it also buffers. That's the advantage. But this one, as long as it sees destination MAC address, after getting the 464 byte, it starts sending the message to destination. It does not do FCS, frame check sequence. And because of that, you could have error. And this may lead to bandwidth issue. Because if the switch propagates too much error, there will be a problem. It's going to be using the bandwidth to process the error. And this cannot support different speeds from ingress to egress. So you see there's an advantage for stall and forward. And then over the cut through. And I think the last part is this domain, switching domain. So what do you call a collision domain? A domain where collision can happen or it can take place, and this was in the days of half duplex. Switches eliminate collision domains and reduce congestion. When there is full duplex on the link, the collision domains are eliminated. You can't have full collision again. When there is one or more devices on half duplex, there will now be a collision domain. There will now be contention for the bandwidth. Collisions are now possible. If this place now, this connection now is half duplex, I want to send, the switch also want to push something down, collision can take place. And whatever is the bandwidth of this link, we are sharing it. I use it to send, use it to send to me. I use it to send, use it to send to me. But if it is full duplex, you are sending on your own, I can receive on a different link. Most devices, including Cisco and Microsoft, use auto negotiation as the default setting for duplex and speed. This was back then. You don't have half duplex again. But in the days of half duplex, they use auto negotiation. In case you are running half duplex, I need to know, I need to find out from you so I don't run full. Or I am running full duplex, you need to be able to discover that I am running full duplex and come to full duplex so that we don't have what we call duplex mismatch between between the two devices sending to themselves. And you can have duplex mismatch, and you can also have speed mismatch. You don't really have much of a problem with speed mismatch, but there is serious problem with duplex mismatch. Okay, and the last part I believe is broadcast domain. What is broadcast domain? I just talked to you guys about HAP. I know your IP address. I'm looking for your MAC address. I'll send a HAP request, as we call it. That's a broadcast. So what happens on my message? Everybody will process it. If this guy here should send a broadcast now, it will go to the switch. The switch will send to everybody. And guess what? This switch will forward it to the other switch. This switch will replicate it and send to everybody. Now you can imagine I'm sending a broadcast. You are sending a broadcast. Somebody is sending a broadcast. Another person is sending a broadcast. This is a broadcast domain. The broadcast can stop and fill that environment. We added one more switch. We have just enlarged our broadcast domain. The bigger your broadcast domain, the bigger your headache on the network. That is the reason why we introduce a router to break our network into multiple broadcast domains. That is what we also call segmentation. We segment the network because a router doesn't forward broadcast. If there is a broadcast on one segment like this, it only fills this environment. It cannot move to the other side. So router, the broadcast will get to the router will push it back. The broadcast will get to the router will push it back. Even if you have 4 segments, 20 segments, 30, 40, 50, everybody will have their own broadcast in their own domains. It can't pass through the router. With that, you are able to ensure optimal performance on your network when you do segmentation. Because too many broadcasts can cause congestion and poor network performance. There's something called broadcast storm. Everything will just choke because too many people are sending broadcasts on the network. And it's not only when you are looking for MAC address. You can be looking for an IP address, but that one is rare. You send what is called RAP request, reverse address resolution protocol. That one is rare. So how do you alleviate network congestion? Summary: move to full duplex, segment the network, and you are good to go. Like in your university right now, I don't know how many users you have on your network. It's good to have a segmented network. And so that's the end of that. That one is not much. You've done it in CCNA1, some part of it, I believe. Any question, please? Any question? Hello? Okay.
Is everybody, I think you should just talk so that we know that your TTR is 0. Ahmed, are you there?
It's like they are not there or they've left also.
Oh, I think they're there.
Huh?
Prof, are you there?
Yeah.
They're there. Mr. Adekunle, are you there? Dr. Kwemi, are you there too?
Yeah, I think he stepped out of his office. It's not there.
Okay. So, Prof, back to you. Tomorrow we're still going to maintain 8:30. Still maintaining
Yes.
4 hours.
Yes.
So, any feedback? I welcome feedback, please. Observation. Things to be improved on. I'm too fast, I'm too slow.
No,
We are going too long on the online. We should take break after 1.5 hours, something like that. Let's just have that brief discussion before we call it a day. Observation, feedback.
No, they should. Maybe I think I'm fine, but let the other people speak of. I think all is fine as far as I'm concerned, but the floor is open.
Okay.
If you have any
I think I'm
comments,
fine too. I think the only thing we will need the recording because I got distracted with me with a meeting. I had to attend the meeting while training was going on, so I couldn't for like 30 minutes or 1 hour. I think I was out.
Okay, I
So
will send the recording immediately.
yes,
But I
so
will
it's
have
already
loved,
configured.
I will have loved you guys to listen to another recording of mine that I did for other set of people on the topics we are going to take tomorrow. It's on VLAN and inter-VLAN routing.
If you can help us send it.
Yeah,
If
if
you
it is
can help
possible.
us send it.
If it is possible, so if you're able to go through those ones, then tomorrow it will be faster for us as I'm talking, teaching, doing labs on those ones. Then it will be good for us.
And so please help us send it with the recordings of this one that we just finished, so that if I've been able to sit through. So if some people are not able to sit through, or one gets distracted anyway once in a while, somebody will enter the office. So we would, if you send to us, we will try to watch the video before the class.
It's okay, sir.
Thank you so very much, sir.
All right, so
Please do
you're
have a
welcome.
nice day.
And you too. Bye, sir.
I
Bye,
hope you
everybody.
of course activate CCNA too, so that
I'm going to do it right away.
do you have our emails already?
No, I will just import you people from CCNA 1 and put you in CCNA 2.
Okay.
I will import from that class.
That's perfect then.
Yeah.
Okay. Thank you, sir.
Right.
And please
See
do
you
have
tomorrow.
Bye-bye. See you tomorrow, 8:30. Thank you, guys.